there's nothing around. Just the eternal, endless whiteness of Greenland's snow and cold winds blowing into your face. Nothing hints at the impending catastrophe. You take another step and freeze in horror. An abyss is spreading at your feet, bottomless and dark. If you had made a bigger step, it would have swallowed you. That infamous Greenland's hole. It happened in the middle of the 2010s. A group of geologists were scanning the surface of Greenland's Hiawatha Glacier using radar when they spotted something very, very strange. It was a giant pit, more than 980 feet deep and almost 20 miles wide. That's big enough to fit inside Washington, D.C. or Paris. After staring at their radars for quite a while and scratching their heads, researchers decided to find out what could have made such a huge hole. Could it have been good old erosion? A raging volcano? An asteroid impact? A giant sandworm? Ugh, I might have gone a bit overboard with this worm idea, but you never know with these ancient glaciers. Anyway, in our case, one mystery seemed to lead to another, which had been puzzling scientists for decades. And to solve both of them, scientists needed something super common, but at the same time very important. Quartz, one of the most abundant materials in Earth's crust. But before we dig deeper into this topic, let's make a small detour and talk about a pretty bizarre phenomenon called the Younger Dryas event. To see what it was like, we need to go deep into the past. As far back as 12,900 to 11,600 years ago. During that period, the planet became much colder, especially in Europe and North America. Now, let's talk a bit more about that weird climate change in the Northern Hemisphere. There are a few theories, one that involves a change in currents in the Atlantic Ocean. Another speaks about something large kicking tons of dust into the air and effectively blocking sunlight. The two most popular and likely hypotheses mention a volcanic eruption and an asteroid impact. Indeed, there was a volcanic eruption on the territory of modern-day Germany at around the right time. But there's also a probability that a space object struck the planet during this period too. And now let's get back to the hole scientists found in Greenland. When NASA's Ice Bridge program and Germany's Alfred Wegener Institute discovered it, it seemed they had finally found the reason for the Younger Dryas event. But was it really an asteroid that created that impressive pit and caused temperatures to drop all over the Northern Hemisphere? To test this theory, the researchers needed quartz. The thing is, in its pure form, quartz has a very simple structure. It's made from interlocking silicon-oxygen tetrahedra. Efficient and so pretty. Just look at these six-sided prismatic crystals. Since its structure is so simple and the components are so common, you can find quartz almost in any rock on the planet. At one point, magic happens. Larger rocks erode away, pushing out tiny bits of quartz sand. The scientists exploring the mysterious pit gathered the quartz sand that had been washed out from underneath the glacier. It was like looking at the rocks at the very bottom of the hole without having to actually get all the way down there. Very handy. So, while examining the material, they discovered quartz grains with the telltale signs of terrible catastrophe. They had PDFs all over them. No, I'm not talking about the document format. PDFs stand for planar deformation features, and they look like lines etched into the crystal surface. These lines are a sign that you're holding shocked quartz. It forms under immense pressure, when the internal crystals are pushed out of alignment. But the most exciting thing here is that shocked quartz only appears under the influence of powerful forces, like massive impacts or terrifying explosions. In other words, finding this poor shocked quartz under the Hiawatha Glacier could be much needed proof that the hole was an enormous impact crater that formed when something equally enormous crash-landed there. Based on the size of the crater, this space object probably was a bit more than a mile across, which is twice the height of the Burj Khalifa Tower in Dubai. A meteorite that big would have looked 3 times as bright as the sun when traveling across the sky, and it would have hit Earth with an immense force. The impact would have been so great it'd have vaporized rock and thrown debris for hundreds of miles away. The sky would have filled with dust. It would have dimmed the sun and led to a temperature drop all over the planet. And guess what? The last part about decreasing temperatures got the researchers super excited, because it opened up a possibility that the impact could have been connected to the Younger Dryas event. To prove this idea, scientists decided to use quartz again. They examined it more closely, trying to date the impact. Well, they were in for an even greater shock. The Hiawatha crater turned out to be not 12,000, but 58 million years old. On the other hand, the researchers were disappointed that they hadn't been able to confirm their theory. The crater couldn't explain the Younger Dryas cold snap, but on the other hand, it was still an amazing discovery. Now, get ready for one final twist to this story, and it revolves around quartz again. Other scientists have recently discovered more deposits of shocked quartz all over what is now the eastern USA. It was hiding in sediment layers dating to just before the Younger Dryas. Interestingly, there aren't any craters around those sites whatsoever. But quartz can't lie. It provides evidence of a powerful explosion. It makes scientists think that their impact hypothesis might still be true, but instead of a collision, it could be an airburst. A massive comet could have broken up while entering Earth's atmosphere around 12,000 years ago, and the fragments could have exploded before reaching the ground. It would have caused catastrophic mass burning throughout the North American continent and messed with the climate so much that the Younger Dryas would have been triggered. Well, I guess we need to wait a bit longer for scientists to find some further proof of this hypothesis. But it doesn't mean we don't have any more curious phenomena to explore in Greenland. Take these fascinating holes. They sure are kinda smaller than the monster we were talking about. They're called moulins, and they carry surface meltwater all the way down to the base of the Greenland ice sheet. And they have prepared some surprises for us too. Apparently, they're way larger than we previously thought. That's what a recent study based on observation and first-hand exploration claims. Even more interesting, this high volume might influence the stability of the ginormous ice sheet in question, as well as the speed at which it's sliding towards the sea. Researchers think that increased water depth and pressure inside moulins might lubricate the base of the ice sheet, making it move faster. You know, the way an ice cube slides more easily on a thin film of melted water. Until recently, we knew too little about the real size of moulins and how much water they can hold. But now, we know that moulins can be giant. The team made 2 trips to the Greenland ice sheet in 2018 and 2019. And during each of them, they used ropes and climbing equipment to drop around 330 feet into 2 separate moulins, almost touching the water's surface. Those who did it described the experience as intimidating. Picture this. Your back is over the edge. All you see is bluish ice going down and blurring into blackness. And the only thing you hear is occasional sounds of crashing ice. It must be extremely unnerving.
The floor is lava! Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the endgame here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first.
It was April 2025 when geologists went back to Yellowstone's Norris Geyser Basin for the first time this year. And while doing their usual check, they realized that something was different this time. Where there used to be just a boring patch of ground, now there was a giant hole, about 13 feet wide, filled with weird, milky, light blue water. Everyone was terrified. Was it the sign that the Yellowstone supervolcano was ready to erupt? If so, it would be a worldwide disaster, the kind that destroys cities. According to the U.S. Geological Survey, if such an eruption occurred, the after effects would be felt all over the world. To start, the areas immediately surrounding Yellowstone would experience pyroclastic flows. That's the lava that erupts out of a volcano, including a high-density mix of volcanic gas, ash, pumice, and hot lava blocks. Those flows would destroy everything they touch, and an eruption of Yellowstone would send them into Wyoming, Idaho, and Montana. Areas further away from Yellowstone would escape the flows, but they would experience falling ash. It would come down heavily in the states closest to the epicenter. The ash would be especially dangerous for anyone breathing it in. The weight of the ash would also pose a serious threat. It would smother crops and collapse buildings as it piles up. Tragic consequences would be countless, but we'll talk about them later, because soon after the discovery, the weird pit surprised even experts. Geologists found rocks scattered everywhere. Some were about a foot across, and all of them were dusted with gray mud. This mud matched the walls of the new spring. It was like the place had simply exploded, but nobody had actually seen it happen. The team checked old satellite images to figure out when it appeared. In December 2024, the ground was totally normal. By January 6, 2025, a little dip had formed. And by February 13th, that water-filled hole was finally there. But the weird thing was that the sensors that usually pick up major hydrothermal explosions didn't detect anything. There was no giant blast or warning signs. Later, it turned out that this puzzling opening in the ground hadn't just popped up in one huge explosion. Instead, it formed from a bunch of smaller bursts over time. Little explosions first threw out rocks, then mud, and eventually created the pit. With time, it filled with silica-rich water. That was a huge relief for everyone. Yellowstone sits on a supervolcano, and its big explosions are a nightmare scenario. Luckily, this time, it was just a slow-building, small-scale explosion. It was dramatic, sure, but totally manageable. You see, Yellowstone National Park is full of geysers, hot springs, and all kinds of natural landscapes. But under the surface, things get incredibly intense, all because of the supervolcano. Now, supervolcanoes are often extremely large. They often have no cone at all, since they're typically the remains of gigantic magma chambers. Once, those chambers flared up, leaving behind a caldera. They're usually located over hotspots. It's no surprise that supervolcanoes can produce super eruptions, and when they do it, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes form when huge volumes of scorching hot magma escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. So, a pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more and more magma is trying to get to the surface. And then, bang, a super eruption occurs. Now, back in 2015, researchers at the University of Utah mapped out the main magma chamber of the Yellowstone supervolcano and were shocked by its size. And then, they found another one below it. Together, these underground magma pools could hold enough molten rock to fill the Grand Canyon 11 times. All that magma pushes up on the ground above, which is why Yellowstone rises about an inch or two every year. That slow lift might not sound like much, but combine it with the fact that Yellowstone is still an active volcano and has a volcanic explosivity index of 8, and it's enough to make you wonder what could happen if things went south. And yes, Yellowstone has indeed been a bit jumpy in recent years. In March 2023, there were 354 earthquakes in the area. Most were tiny, but the biggest hit a magnitude 3.7, part of a swarm of 106 quakes. Now, before you freak out, experts from the Yellowstone Volcano Observatory say there's no need to panic. No eruption is coming anytime soon. Volcanoes don't stick to a schedule. Just because Yellowstone hasn't erupted in a long time doesn't mean it's about to blow. The park is stable for now, but scientists are keeping a close eye on everything underground, the quakes, the rising ground, and even temperature changes, just to be safe. The superhot plume of magma, a hotspot under Yellowstone, has been churning for 17 million years. The Earth's crust slowly moved over it, making the hotspot leave a trail of volcanoes stretching more than 450 miles along the Snake River Plain. Most of those ancient ones are now buried under layers of lava and sediment. In just the past 2.1 million years, Yellowstone has unleashed 3 cataclysmic eruptions, so massive they managed to reshape the land. Each explosion sent pyroclastic flows, rivers of searing hot rock, ash, and pumice racing outward for miles. The debris piled up in layers hundreds of feet thick, some forming solid lava-like rock. When those eruptions emptied the underground magma chambers, the roof collapsed, forming the massive calderas we see today. Even after those mega eruptions, Yellowstone didn't stop. Between 180,000 and 70,000 years ago, enormous rhyolite lava flows, sometimes over 144 cubic miles, poured out. Some flows followed north-south vent lines. The West Yellowstone flow erupted around 110,000 years ago. The Nez Perez Creek flow followed 160,000 years ago. If you stand at Madison Junction on the caldera's northwest rim, you can see it, a cliff that formed when the Lava Creek Tuff eruption collapsed the land 640,000 years ago. And inside the caldera, you'll see the hardened lava flows snaking across the floor. Figuring out when a supervolcano might blow is like being able to read nature's warning signals. Thousands of years before a massive eruption, the heat underground starts building, and the magma chambers become like ticking pressure cookers. Little signs start showing up. Gas bubbles escape as the pressure shifts, and earthquakes shake the ground. The land above slowly rises. Cracks appear. Hot springs and geysers start acting up, heating even more than usual. Now, what would happen if Yellowstone erupted? Remember those pyroclastic flows we talked about before? They can contain two parts: the lower flow of the hot lava that moves at ground level, and a cloud of ash that follows above the lava level. So the two of them would devastate huge areas. The ash would even reach Europe within 3 to 4 days of the eruption, but it wouldn't be so bad there. After that, it would only take around 2 to 3 weeks before cooler temperatures set in around the globe, all thanks to the sulfur gas that would get to the upper atmosphere after the eruption. Scientists predict that global temperatures would drop by up to 10 to 12 degrees. These consequences could last for 6 to 10 years, putting an end to monsoons, which could cause widespread famine in Asia. Scared? Well, don't be. The good news is that scientists don't believe that the sleeping giant under Yellowstone National Park will wake up in our lifetime. Experts say the next Yellowstone eruption won't likely happen for hundreds of thousands of years. And even then, it may not be that bad, because scientists have discovered that the magma lurking within Yellowstone is actually split up amongst 4 different chambers. Not only that, but some of the reservoirs of magma are likely to cool down and solidify, lessening the chances of an eruption. So, while an eruption does sound like it would change the landscape of the world, it's very unlikely to happen anytime soon.
This area might just be the most important spot in America right now, as it is worth over $1 trillion. There's something incredibly valuable hidden right here at Thacker Pass, and it is going to shake things up, not just in Nevada, but in the U.S. economy and its global relations. The McDermott Caldera is a massive area, about 28 miles long by 22 miles wide, stretching across northern Nevada and southern Oregon. It's in Humboldt County, a quiet, rural place with just one main city that's going to change a lot in the next 5 to 10 years. That's because they found white gold there. We're talking about lithium. And to explain why this metal is so important, we need a scale. On one side, we place a chunk of lithium, and on the other, an apple. What do you think will happen? If both have the same volume, the scale is going to tip toward the apple. That's because lithium is super light. Its density is about 0.3 ounces per cubic inch, which makes it the lightest solid you can find at room temperature. Lithium is also extremely reactive. That means it combines with other elements very easily, and it can catch fire just as easily. Mix it with water, fire. Expose it to air, yep, fire again. But when you combine its lightness with its high reactivity, you get a material that's perfect for batteries, like the one powering your smartphone, laptop, or even your electric car. Nevada's been hiding this treasure for about 16 million years. The McDermott Caldera used to be a volcanic hotspot, spewing molten rock and creating a huge lake filled with mineral-rich waters. Over time, that lake dried up, leaving behind thick layers of clay loaded with lithium. Right now, Thacker Pass mine is sitting on one of the biggest untapped lithium reserves in the world, worth about $1.5 trillion. If everything goes as planned, they expect it to produce about 40,000 tons of high-quality lithium a year. And that's enough to make batteries for up to 800,000 electric cars. Like I mentioned earlier, this metal is the backbone of modern batteries. And with the world racing toward green energy, the demand for lithium is skyrocketing. Since 2020, its price has gone up more than 10 times, making it the most expensive battery metal in the world. That means it's way more expensive than magnesium, nickel, cobalt, and other materials used in rechargeable batteries. Right now, we're using about 1.16 million tons of lithium per year, and roughly 85% of it goes into making batteries, mostly for cars. Between 2030 and 2040, experts think we will need to double the money we're putting into production, from $94 billion to $188 billion. At the same time, investment in batteries will jump by over 200%, reaching $686 billion. Finally, by 2050, the demand for lithium is expected to be more than 10 times higher than what we're producing now. Sorry, I know that's a lot of numbers, but I just want to show how important Thacker Pass will be for the whole world. This mine is going to be key to keeping everything running. I mean, literally, since most of the future demand will be for things like cars, electric bikes, scooters, and renewable energy storage. Nevada could also be the epicenter of a global energy revolution, with the US aiming to cut pollution by 50% by 2030. A big part of that is replacing gas-powered vehicles with electric ones. And to make that happen, America is going to need a whole lot more lithium than it's producing right now. Nowadays, most of the metal used in the United States come from countries like Chile and Argentina. So if America wants to be a leader in this market, it really needs to invest more and more in projects like Thacker Pass. But there's another challenge. Finding lithium in a mine is one thing, but refining it is another story. Just like diamonds are carefully cut and shaped to bring out their sparkle and sold in rings and necklaces, something similar needs to be done with lithium. The raw material that comes from the mines has to be refined into a pure form that can actually be used in things like batteries. And China pretty much dominates this part of the market, and they're responsible for about 75% of global lithium-ion battery production. In other words, it doesn't matter if a country finds this powerful metal on its land, it will probably still need China to help refine it. So, the US is eager to strengthen its supply chain. In fact, they're so excited about this possibility that authorities have invested over $2 billion in loans into the Nevada project. Because of that, Thacker Pass could make the US a leader in lithium production worldwide. If their estimates are right, the McDermott caldera could hold nearly half of the world's known lithium reserves. It would almost double the reserves found in Bolivia's salt flats, for example, which used to hold the record for the world's largest deposit. This discovery is about to change Humboldt County for good. Those quiet streets surrounded by nature will never feel the same again. The mine will need about 2,000 workers who will probably move there from other cities. Those workers will need houses, hospitals, schools for their kids, and all the necessary services. Do you see how it's like a ripple effect? For every person hired to work on the project during construction, 6 more people will get hired in the state to support them. Thacker Pass is also going to have a huge impact on the economy, not just in Nevada, but all across the country. People expect the mine to be active for 35 years, and each year it's expected to generate over $2 billion. But here's the thing. In Thacker Pass, they'll be extracting lithium from clay, and this process has never been done on such a huge scale before. So it's kind of a hit or miss. But if it works, it could completely change the industry. Big question. Who's interested in all this? Well, we've got 3 big companies eyeing the lithium market in the US. First, there's ExxonMobil. The oil giant wants to start producing lithium by 2027. and they have plans to become the top supplier for electric vehicles by 2030. Then there's General Motors, the company behind big car brands like Chevrolet and Cadillac. They're so interested in this business that they agreed to pay $625 million for a 38% stake in Thacker Pass. And finally, Tesla. In 2023, they started building a factory in Texas to process lithium. It's all part of their plan to handle more of their supply chain themselves. Now that you know how important lithium is, you might be wondering, what if we run out? Well, that could happen, since it comes from mining and, just like gold, is a finite resource. But that doesn't mean we'd have to give up smartphones or electric cars. If we ever run out of this metal, we'd probably find new ways to produce batteries. In fact, some experts think thermal batteries could be the next big thing. They store extra energy from renewable resources like wind or solar power, which are very cheap. So they represent a new way of storing energy at a small fraction of the cost. Nowadays, they're primarily used for powering the production of steel, cement, and chemicals. Thermal batteries are also being used to heat and cool large buildings. However, more and more projects are focusing on bringing this technology into private spaces, like houses and apartments. Experts are optimistic that initiatives like these could make thermal batteries as well known as electric batteries, and they might soon become a regular part of our daily lives. You certainly know the Great Wall of China, but did you know the country just built a second one? This one, though, isn't made of bricks and stones, and it doesn't keep out invaders. Instead, it's made of plants and serves as a last line of defense against something that's been slowly but relentlessly taking over the country: sand. This big barrier surrounds the tricky Taklamakan Desert, located in the northwest part of the country. This area is huge, covering an area of over 130,000 square miles, just a bit smaller than Germany. It has some massive dunes, some towering over 300 feet, which is taller than a 30-story skyscraper. The temperatures are crazy too, with scorching heat in the summer, often going up to 104 degrees Fahrenheit. But it's not just the size or the temperature that makes it so fearsome. It's the way it moves. Yep, this is the world's second largest shifting sand desert. 85% of it is made up of dunes that move as they're carried by the wind. The sand is constantly swallowing roads, villages, and farmland in its path. The more adventurous travelers who cross the desert by car or bus can actually see the sand moving across the road. But they also notice something interesting on the horizon: green bushes. Don't mistake it for an oasis, though. That's the new Great Wall, or rather, the Green Wall. A massive project designed to fight desertification and control dust storms. But is this really such a big deal? Absolutely. China has been battling desert expansion for quite some time, as one of the reasons is that they need more space. You see, China is one of the most populous countries in the world, second only to India. And now you might be thinking, okay, but their territory is huge, so there's plenty of space for everyone. Well, technically, yes. After all, we are talking about a country that spans over 3 million square miles, almost as big as all of Europe. Even though China is huge, not all of its land can be used. A big part of the country is covered in arid terrain, places that aren't really suitable for construction and have very few people living there. There are 12 major deserts, which make up nearly 20% of China's territory. And this problem is only getting worse, as the wasteland keeps expanding. In the future, deserts could take up as much as 44% of the country. Even the capital, Beijing, is at risk. By the way, the capital is already being constantly hit by severe sandstorms, forcing residents to stay inside to avoid the heavy air pollution. For years, China's deserts have been spreading at a rate of more than 1,300 square miles a year.
Take the Ningxia-Hui region in northwestern China, for example. It's surrounded by 3 major deserts and has been battling desertification for over 60 years. And as of 2010, 57% of its land had already been affected. This isn't just an inconvenience. Desertification destroys farmland, crippling food production. It also forces people to abandon their homes after watching their village get buried in sand. Authorities are working hard to relocate these people to safer areas. And for those who choose to stay, life isn't easy. Farming, for example, is becoming more and more difficult. For example, farmers in the town of Tongunawa say that when they were kids, they could dig and find water tables about 6 feet deep. Now, they have to dig about 16 feet just to reach water. And since the soil isn't as soft or fertile as it used to be, they also have to use a lot more fertilizer on their crops. Okay, but why is all of this happening? There's not just one main reason for desertification. It's more like a combination of factors. In China specifically, studies show that about 20% of the blame is due to the planet's rising temperatures. I mean, yes, deserts are already environments that are prone to drought, but the increasing heat makes the dryness even worse. And it's a fact that it rains way less nowadays than it did a half a century ago. So, this climate disruption mainly affects the northeastern and northwestern parts of China. But in areas near the Muaz Desert in north-central China, there's another factor making the country even more arid. And that's us, humans. The equation is simple. More people, more desertification. Between 1997 and 2008, China's population grew by nearly 100 million people. With more people, they need more food, more space, and more resources. So they start cutting down trees, clearing land for farming, and using up all the natural resources around them. It's like the land is just getting stripped of everything it needs to stay healthy. That's how desertification speeds up. But the desertification problem in China can actually affect your life, even if you're on the other side of the world. Here's the thing. Soil stores a huge amount of carbon. But as the land degrades, not only does it lose the ability to hold on to that carbon, it can actually release it into the atmosphere. And when more carbon goes into the air, well, we all know how that story ends, right? Luckily, there are a few ways to keep China from turning into one giant sandpit. One solution that authorities have come up with is building the green wall we've been talking about in the Taklamakan Desert. By planting a massive amount of trees, shrubs, and other vegetation around the deserts, they're able to prevent sandstorms. The thing is, the wind and sand action at the edge of the desert is super intense, and the sand dunes keep expanding outward. This green belt also helps protect infrastructure. By locking in the desert's edges, it safeguards things like railways and roads. Building such a powerful barrier is a huge engineering feat. The first challenge is obviously the size of the desert that needs to be contained. It's massive. Then there's the height of the dunes, some of which reach crazy heights. The tallest dunes are as high as a skyscraper with 100 floors. On top of that, engineers have come up with solutions to make the greenbelt thrive in the dry climate, which makes reforestation practically impossible. So this is definitely not a project that happens overnight. Just in the Taklamakan Desert alone, it took 40 years to finish the first 1,700 miles of the greenbelt. To finish the rest, they needed a group of 600,000 people planting desert-tolerant species like desert poplar, red willow, and saxaul trees. Speaking of that, even the plants they're using in the project can create economic opportunities. For example, there is the desert hyacinth, also known as the ginseng of the desert. This plant actually thrives in dry environments, and it can be easily sold since it's traditionally used in food in China. Besides the plants, they're also setting up solar power bases around the desert. Installing solar panels there doesn't just generate power, it can also help keep the sand dunes from moving. This huge man-made barrier, which stretches about 2,000 miles around the Taklamakan Desert, was finally completed in November 2024. And it looks like all the hard work from the engineers really paid off. The portion of the country covered by deserts dropped from 27.2% in the previous decade to 26.8%. That's pretty amazing. But where did all that sand go? It's not like it just vanished into thin air. It's more like it's been contained now. The sand that used to move around is not spreading anymore, at least not taking over more land. The battle against desertification is far from over, but one thing is clear. China is no longer just fighting its deserts. It's actually winning.
Hey, quick question. How many continents are there? 7? Maybe 5? There's no correct answer. According to different approaches, the range is between 4 to 7. But it might actually be as many as 8. Chances are, a lost continent has recently been found between Greenland and Canada. This new continent discovery could also potentially be the key to how microcontinents form. What does this all mean, and what makes this hidden landmass near Greenland so important? Now, if you're like me, and if you are, then there's 2 of us, when you hear the word continent, you probably think of land like Europe or Africa, places above water where people live. But in science, a continent isn't about being above sea level. It's about what the land is made of. Earth's outer layer, called the crust, comes in 2 main types, continental and oceanic. Continental one is thicker, lighter, and made of different types of rock, like granite. The oceanic crust is thinner, heavier, and made mostly of dark volcanic rock. Now, the discovery under the Davis Strait between Greenland and Canada appears to be a piece of continental landmass, even though it's under the ocean. Scientists call it a proto-microcontinent because it began to break off from a larger terrain millions of years ago, but never quite made it. As tectonic plates slowly shifted, the Earth's crust in this region stretched and cracked. One chunk started to split away, but for some reason, the process stopped. It didn't drift off like a full continent, and it didn't sink like ocean crust either. Instead, it stayed right there, floating beneath the waves all this time. This makes it different from true microcontinents, like Zealandia, which have completely detached and now exist as separate tectonic blocks. Zealandia is a submerged microcontinent near New Zealand. About 94% of it lies underwater, but because it's made of continental crust, many geologists say it qualifies as Earth's 8th continent. However, Zealandia is still debated because it's too big to be a microcontinent, and there's no official global body to define its status. There's no global organization like the UN or some kind of international geology council that can declare, hey, this is a new continent. Unlike Madagascar, which is fully above sea level and widely accepted by geologists as a classic example of a microcontinent, Zealandia is still waiting for a proper label. I know you're probably wondering, isn't Madagascar an island? The simple answer is, it's both. It's the 4th largest island in the world, completely surrounded by water. But it's also geologically considered a microcontinent because it broke off from the supercontinent Gondwana around 88 million years ago and is made of continental crust, not oceanic crust. Unlike volcanic islands like Hawaii, this isn't just built from lava. It's a real piece of ancient continental crust. So, Madagascar checks both boxes: island by geography, microcontinent by geology. And that's exactly why these discoveries can be fascinating. Just like Madagascar stands out above the waves, this newly discovered landmass under the Davis Strait stands out beneath them, thanks to its unusual structure. What makes it stand out is its unusual thickness. Most of the ocean floor is thin, like metal. This is more like packed clay, layered with continental materials. Underneath this cozy comforter, scientists discovered some odd layers of rock, unusual because they're not where they should be. These layers act more like the materials found on continents rather than those typically seen on ocean floors. There are hints of granite-like formations and distinct magnetic properties, which suggest that this stuff is similar to what makes up dry land. The size is also remarkable. The proto-microcontinent is about 12 to 15 miles across, which makes it roughly the size of a mid-sized city, like Manhattan Island at 6,500 feet underwater. The fact that it sits right under the Davis Strait, one of the widest ocean passages on Earth, makes it one of the largest submerged continental fragments we've found. According to researchers, this landmass began to form between 58 and 49 million years ago, when Greenland and Canada were slowly drifting apart. Maybe they just weren't getting along. Hey, it happens. As they pulled apart, the crust under the Davis Strait stretched, and one of the main fault lines shifted. But the breakup didn't finish. Around 48 million years ago, the rifting stalled and Greenland's motion away from Canada slowed dramatically when it later bumped into Ellesmere Island. It's like a car swerving off and then back onto the freeway, a turn that was never completed. That's basically what happened. A chunk of land got stuck between the motion. It didn't float off into the ocean like a new continent, and it didn't get pulled down into the Earth either. It just stayed where it was, stranded beneath the water. But that's not all. This chunk has its own fault system, and scientists say it actually looks like a miniature version of the San Andreas Fault in California. Now, a fault is basically a crack in the Earth's crust where sections of rock slide past each other. Think of it as a place where the Earth's surface split and tried to slide sideways. In California, this movement still happens today and can cause earthquakes. But under the Davis Strait, it's a different story. The movement started, then suddenly stopped, like hitting pause in the middle of a big shift. It's a frozen moment in the planet's past, preserved right beneath the waves. For geologists, that makes the microcontinent under Davis Strait incredibly valuable. That sudden pause in motion helps explain why some chunks of land break away cleanly, while others twist, stall, or disappear. But this isn't just academic. By studying how continents break apart or stall, scientists can better predict future shifts in land, fault lines, and seismic activity. And predicting earthquakes and geological hazards could prove quite valuable to everyone. Knowing how microcontinents form could help us anticipate how the planet's surface might shift over millions of years, which affects everything from climate models to resource availability. But even just the technological advancement needed for such discoveries is greatly beneficial. The same tools used to map this hidden land are used for oil exploration, laying undersea cables, climate monitoring, and even search and rescue missions. Speaking of technology, for a long time, this hidden landmass near Greenland remained invisible. Just 10 or 15 years ago, the ocean floor under the Davis Strait was basically a mystery. It's deep, almost frozen, obviously not the easiest place to explore. But today, thanks to modern tools, a new continent discovery could be just a matter of time. Scientists can finally see and hear what's going on under all that water. First, they use seismic reflection imaging. That's a method where ships send sound waves down to the ocean floor and record how they bounce back. Various layers of rock reflect sounds in different ways, which helps build a picture of what's hidden underneath. It's kind of like how bats use echoes to see in the dark. Satellites also play a role in collecting gravity data. This may sound strange, but different types of rocks have slightly different weights. Heavier rocks create stronger gravitational pull, and satellites can measure those tiny differences. Another tool commonly used for these explorations is underwater sensors, which sit quietly on the seafloor and listen for natural vibrations, like mini earthquakes or shifts in rock. These vibrations help scientists figure out what the crust is made of and how thick it is. They're basically ears on the ocean floor. They also most likely used AUVs, or autonomous underwater vehicles, basically robot submarines that can scan the seafloor in high resolution even under thick ice. In any case, scientists are very excited because this new continent discovery is more than just a geological surprise. It's what they call a natural laboratory. The study of the microcontinent Davis Strait offers a rare opportunity to understand how microcontinents form, evolve, and sometimes fail to fully separate. It also reminds us that Earth's crust isn't as neatly divided as we once thought. Beneath the ocean, there may be other hidden landmasses near Greenland or elsewhere, almost continents, just waiting to be found. This lost continent of Canada may not have made it as a fully fledged landmass, but its discovery is already reshaping how we view plate tectonics. And thanks to advances in technology, places we once ignored are now offering up secrets about the planet's deep past, and maybe even its future.
Dinosaurs, big ancient bugs, creepy spiders, and scary insects are all cute animals compared to the monsters that lived on Earth about 500 million years ago. For example, here's a creature that swam in the water like a stingray and had 3 eyes. Its mouth was like a pencil sharpener. 2 long claws with forked tips like pincers protruded from its head, and its gills were somewhere in the back. This is not a thing from a sci-fi movie. This is Mousura. Its remains are preserved in excellent condition. Let's look at it more closely and study other similar monsters. The Cambrian explosion. Remember this name. This period is also called the biological Big Bang, the time when a huge number of different living creatures began to appear in the ocean, large, small, and tiny. The ancestors of almost all modern animal groups were most likely born during the Cambrian explosion, which lasted from 541 to 485 million years ago. It was a time when the first truly effective and terrifying predators appeared on Earth. One of them was Mousura. It's only the size of an index finger, but you would never want to meet such a creature while swimming in the sea. It's scary to imagine what it could do with its pencil sharpener-shaped mouth. And you probably wouldn't be able to hide from it because, come on, it had 2 eyes on the sides and 1 big eye on its forehead. Mousura belonged to a group of arthropods. Scientists called it a sea moth since it reminded them of a moth. This thing used a flap-like apparatus similar to wings to float in the water like a stingray. This monster was quite creepy, but its appearance may seem familiar because it's a distant relative of modern spiders, crabs, centipedes, and moths. Scientists found several 506 million-year-old Mousura fossils, but unlike many other similar finds, these ones have been preserved in excellent condition. The found fossils showed sharp claws, a toothy jaw, and large gills in the tail section. Some parts of the fossil were so clear that they revealed the details of the creature's internal anatomy, including parts of its nervous and circulatory systems and digestive tract. It had jointed limbs like those of modern insects and crustaceans. When this monster swam in the sea, it probably grabbed its prey with long spiked claws sticking out of its head. Many Mousura relatives have claws covered with multiple spikes, which help them grab food. But that ancient creature had smooth claws forked at the tips. That is, it grabbed the prey with those tongs, using them like chopsticks, and then brought it to its mouth. Of course, this is an assumption, and nobody saw how this creature actually did it. Unlike many other similar animals, Mousura's posterior segmented body was studded with gills. Scientists don't know why this was necessary, but they assume that such an unusual breathing system helped to adapt to an environment with low oxygen content. Perhaps Mousura led a very active reproductive lifestyle that required high oxygen consumption. Creepy, dangerous, and reproducing fast. An excellent set of qualities for one of the most dangerous predators of antiquity. But what did Mousura eat? It probably caught different types of worms and small arthropods. It's nice to think that this monster lived so long ago and was so small. But what if this creature was the size of a shark and was swimming in the ocean these days? Perhaps it would become a dominant dweller and people would swim much less along the coast. Mousura lived in the water but was discovered in the Burgess Shale rock formation in the Canadian Rockies. Many mountains on Earth were once the seabed inhabited by strange creatures. One of them was Opabinia. It had 5 eyes, a mouth facing backward, a long trunk and claws instead of a nose. Wait, what? It's too strange even for science fiction, even for outer space. In its eccentricity, Opabinia was perhaps the loneliest creature on Earth. Scientists couldn't find another species that would be similar to this individual until recently. Meet Utaurora. It seems to belong to the same species as Opabinia. Its inch-long body was divided into 14 to 15 furrows. Each of them ended in a pointed flap. Opabinia had the same body, but it's unlikely that both monsters were friends. The difference between their timelines was several million years. It's hard to imagine why these monsters needed such strange body structures. Why haven't modern filmmakers used the design of those animals to create cool space monsters yet? Okay, they were creepy creatures, but what about weird and kinda useless ones? Scientists have discovered Su, a legless creature with no head turned inside out. Huh? This 444 million year old creature was found in South Africa, north of Cape Town. They called it Su after the discoverer's mother. In fact, it's some kind of new arthropod species that may have lived in low oxygen waters. This creature was turned inside out, and the outer shell with the legs and head was lost. Thanks to mineralization, muscles, tendons, and even Su's intestines were preserved on the fossil. It's a great success to find such detailed remains of an ancient creature. However, scientists still can't determine the evolutionary history of this species. They're sure that it was a primitive marine arthropod. Okay, we can see that 500 million years ago, Earth was filled with creepy monsters, which fortunately are now extinct. But what about trees? Were they the same as we see now? Or was there something else? Something creepy? Oh yeah. Scientists have discovered a new kind of living organism similar to a tree or a mushroom. It was gigantic and had a very minimalistic design. Meet the Prototaxites. It's basically just a big stick with a round end poking out of the ground. It was smooth, didn't have the usual tree bark, and looked more like a mushroom without a cap. But scientists have recently found out that it wasn't a mushroom at all. Prototaxites probably belonged to a previously unknown branch of life. Prototaxites is considered to be the first giant organism in the history of the planet that lived on land. It existed about 420 to 375 million years ago during the Devonian period. It was the time when plants began to spread across dry land, forming large forests. Over time, they began to grow leaves and form roots in the ground. Then, the first seed plants appeared. The real colonization of land began. The first arthropods, such as centipedes, arachnids, and other unpleasant creatures, began to walk among those forests. Meanwhile, the water was filled with a huge biodiversity. There was a giant supercontinent on the planet, and smaller parts began to break off it. During this period, Prototaxites towered over the land. Some of these things reached 26 feet high and 3 feet wide. It's like a 3-story house and as thick as a palm tree. But what was it? A plant? A mushroom? Algae, perhaps? Scientists discovered them in the middle of the 19th century, but only in 2007 did they conduct chemical analysis. Research showed that it was most likely a giant mushroom, but in 2025, scientists refuted this conclusion. It turns out this may have been an unknown life form that existed separately from the kingdom of fungi, animals, plants, and protists. Scientists noticed that the inner part of Prototaxites consisted of a number of tubes. There are similar tubes inside mushrooms, but the tubes of that ancient living thing branched and joined differently. They even had a different chemical composition. The main building block of mushrooms is chitin, but the Prototaxites contained chemicals similar to lignin, a substance found in the bark of trees and other plants, and its anatomy differs from the structure of any other organism known to us. What were they doing on Earth? Just chilled and enjoyed the bloom of life? Did they produce some kind of fruit, like a banana with eyes and claws? Scientists don't know. What if it was something that was brought to Earth from outer space? What if they were flowers planted by another civilization? What do you think?
In Mongolia, dinosaurs used to live, and now there are as many horses as there are people and 10 times as many sheep there. It's the emptiest country in the world. The capital has been moved 28 times, and they even have their own Olympics. So Mongolia is located right here, on the plateau of Central Asia, right north of China. It's the 19th country in the world by land area, but it only has a bit over 3 million people. It's like the population of Los Angeles, but having a whole country to themselves. If we don't count Greenland, Mongolia is the country with the lowest population density. It has only 2 people per half a square mile. The United States has 37. Well, that is if we only count people. Mongolia has a lot of livestock, about 67 million. It's 20 times more than the number of people there. Half of that livestock is sheep. Yet of all their animals, the most prestigious one is the horse. There's a traditional saying, a Mongol without a horse is like a bird without wings, and it explains a lot. A person with many horses is considered wealthy, but don't picture huge farms with big stables filled with horses. In Mongolia, having stables is more of an exception. Horses there roam free outside all year long. It costs next to nothing to sustain a horse there because they roam outside and even find food themselves, and the country's nature provides them with enough. Winter is tough because everything is covered in snow, but horses can separate grass from snow. They get frail by spring due to a lack of food, but recover very soon after winter is over. A family can have a sacred horse in their herd. It wears a blue scarf around its neck and is almost never ridden. People there do love their horses, and this tender relationship goes centuries back. There are many songs, stories, myths, and artwork featuring horses. In the Mongolian language, there are about 500 words to describe the traits of horses, and over 200 words to describe the coat color and pattern alone. Horses have a spiritual meaning too. It's believed that they have spirits that can help the owner, and they are also believed to be a transport to heaven, so they were often sacrificed after their owner's passing. Apart from domestic animals, the country is home to some endangered species. Plus, back in the day, dinosaurs roamed the land. The first ever discovered dinosaur egg was found right there. Today, dinosaurs are, of course, extinct, except in the movies. But there are snow leopards in Mongolia, and those are also rare. If you ever do go to this country, you must be careful. Snow leopards are so quiet, you won't hear them approaching you. They make no sound as they walk. But let's get back to geography. The climate in Mongolia can be harsh and unpredictable. Within just one day, the temperature can change by 35 degrees Fahrenheit. The country doesn't have any access to large bodies of water. That's why it's very dry and doesn't get much rain. In the south of Mongolia, there is a part of one of the coldest deserts on Earth, the Gobi Desert. Only 5% of the desert is covered in sand. The rest is bare rock. It has rivers, small lakes, and grasslands, but also gold, coal, and copper. So it's not a very typical desert, but still a desert. Rain clouds don't reach there because of the Himalayan range that keeps the area in the shadow. The desert is expanding every year, because of climate change, of course, but also because of deforestation and changes in land use. The whole country is quite dry with little precipitation, and that's why the inhabitants aren't afraid of the desert. Yes, the desert is populated. There are people living there. They're nomads who are busy with raising cattle. Nomads are people who don't have a settled home. They travel with their animals from place to place following the seasons. When they settle somewhere before their next trip, they set up a tent that is called a yurt. These have been homes in Mongolia for thousands of years, and it's amazing that some people still live in them. The skeleton of a yurt is made of poles, which are then covered with layers of felt and waterproof fabric. The Mongols are a very welcoming nation overall, but the nomads are on a whole other level. They don't get guests often, and they're always ready to greet someone and give them a taste of traditional horse milk. They don't even have bells at the entrance of their yurts, inviting guests to walk right in. Of course, there are also people who live in cities and villages and have settled homes, and they are the majority, about 3/4 of the population. The biggest city in the country is the capital, Ulaanbaatar. Almost half of the country's population is concentrated there in just one city, even though it's the coldest capital city in the world. The average yearly temperature there is 32 degrees Fahrenheit. The average temperature in Washington, D.C. is 60 degrees, and it's 44 in Ottawa. When the city was first founded in the 17th century, It was located about 180 miles southwest of the current place. Then it was moved a little bit 28 times until it finally settled in the current location. Why? Well, back then, most of the population were nomads, so the capital city was a mobile settlement too. Depending on seasons, pastures, water supplies, and many other factors, it moved along with its inhabitants. Now the city is big and settled, so maybe it won't be moved again. But who knows? I know. I have yet to tell you about the Mongolian Olympic Games. The event is called Nadam Festival. It's an annual festival held in the middle of summer that most Mongolians watch. In one form or another, the festival has existed for centuries. Locally, the festival is called the Three Games of Men, and people compete in 3 skills that have traditionally been considered 3 manly skills. So, what are those 3 games? It's Mongolian wrestling, horse racing, and archery. Originally, it was just men competing, but recently women have started participating in archery and horse racing. Mongolian wrestling is a folk wrestling style that's been around for thousands of years. The depictions of it can be seen on many ancient plates found in the area. Today, it's the most popular sport in the country, and Mongolia hosts many international tournaments too. So, of course, there is a wrestling part at the festival, and it's the first game. The rules are quite simple. Whoever touches the ground with anything other than a foot loses. There are no weight classes, no age or time limits, so it takes as long as it needs to win. And yet, they do it with grace. Match courtesy is important. For example, if an opponent's clothes get tangled, the other one is supposed to stop and help solve the issue, even if it means missing a good opportunity to win. At the end of the match, when one participant is defeated, the winner will give them a hand and help them back up on their feet. The game starts with either 512 or 1,024 participants who wrestle in pairs. Every loser is eliminated. The game goes on for 9 or 10 rounds, depending on the initial number of participants, until there is a winner. Then there's horse racing. This is a cross-country long-distance event, between 10 to 17 miles, depending on the age of the horse. Up to 1,000 horses from all over Mongolia can participate in the competition. Then, in archery, people compete in teams of 10. Each archer wears traditional clothes and has 4 arrows to shoot into a wall of woven or wooden cylinders. Knock one out of the wall and you get points, and the team that gets the most points wins.
For every 1.8 degrees Fahrenheit increase in a country's average temperature, the GDP per capita drops by at least 1.1%. To put it simply, with every step you take from the North Pole to the equator, not only do you get hotter, but you also get poorer. Even though life in freezing cold countries can seem miserable, 74.2% of the world's billionaires are concentrated in the global north. And there are at least 4 theories explaining that. The simplest theory is tied to biology. Cold weather is believed to keep germs away, leading to better health and productivity. Sounds good, but I'll challenge that later. Next, there's the sloth theory from ancient Greece, and it's more about climate in general. Greeks believed their ideal weather made them wealthier, while hotter regions were seen as less creative. The third idea is based on economic and anthropological studies. You see, experts noticed some time ago that colder countries have inclusive institutions that offer equal job and life opportunities and protect markets and private property. Naturally, such conditions promote healthy competition and boost wealth. The last idea is tightly connected to the previous one. Long story short, richer countries tend to distribute money better because they're more inclusive. Poorer nations often have extractive institutions where a powerful elite controls wealth. While all of them seem plausible, the truth is, these ideas are borderline insane. Well, you know the theory claiming that cold climates eliminates germs and the population of colder countries doesn't get so sick? I don't want to be the bearer of bad news, but the cold actually makes germs thrive. In the cold, we tend to stay inside with the whole house shut, so we share germs with each other more easily. Not only that, but during winter, the air is drier, creating the perfect environment for the flu virus to flourish. Humans are also more resistant to viruses and bacteria from their own environment because the constant contact with them makes our immune system stronger. If you look back at your history classes, you might remember that most British people struggled with the weather and bacteria found in America, while Native Americans themselves were mostly fine. And what about the sloth theory? Sorry, I don't mean it to sound offensive, but some specialists, they claim that, people in hotter countries tend to be lazier. But the truth is, the sun doesn't make us work less. Yes, the sun can make you a bit slower because you can dehydrate. But you see, the human body is biologically adapted to the climate of the place they're born in. This means that if you live in Canada, for example, you can endure the cold just fine. But Brazilians will probably handle hot days better than you. But if the sloth theory was true, how would you explain that people in Colombia work about 200 hours a year more than those from the United States? In fact, if you live in Cambodia, Myanmar, or Mexico, you're bound to work more than anyone in the world. Besides, hotter countries have a genius way to fight off laziness. It's called siesta. After lunch, it's normal to feel a bit sleepy, and if you have heavier meals like the Spanish and Italians do, you'll get extra slow. This is why after lunch they usually have a siesta, also known as a quick nap, which improves your memory and thinking skills. It may sound like a siesta makes you work less, but people who nap after lunch simply work at different hours of the day. While you make shorter lunch breaks and go home at 6 p.m., in Spain, the lunch break lasts 2 hours, and the workday ends at 8 p.m. They work when it's not so hot outside, and even get to take a power nap. The past is also crowded with people who lived rich lives despite the scorching sun. The ancient Egypt civilization may have existed thousands of years ago, but they were one of the richest civilizations ever, even though they lived in a place that was super hot and super dry. We also have the Aztecs, who lived in Mexico back when Mexico didn't exist yet. This region is not so famous for its cold weather, I can tell you that. But the Aztec civilization still managed to have a capital that was bigger than London, Paris, and Madrid of the time. On top of that, many of the inventions we have today that make a lot of people rich were created thanks to math and science. Two things born in hot places, like Mesopotamia and India. Now, to make all those economic and anthropological studies sound simpler, let's start with the most obvious part. It's true that hotter countries usually make money out of their natural resources. They don't have such strong industries, and the money is concentrated in the hands of the elite. All of this reduces the GDP, that thing that estimates whether a country is wealthy or not. Remember we said richer countries have inclusive institutions? These institutions are basically laws that make sure people have equal job and life opportunities, including nice houses and a good salary. Poor countries are not very good at this inclusive institution thing, but it's not by choice. This is actually a consequence of the age of exploration. In case you were sleeping during your history classes, let me remind you. The age of exploration is that time between the 15th and 17th centuries, when many kingdoms in Europe were exploring the seas and setting up colonies all over the world. I know it feels like this was a long time ago, but many countries that were colonies back then only became independent during the 20th and 21st century. This is why many poor countries don't have solid industries and markets, because their institutions and laws date back to when they were still colonies, and their years as colonies depleted resources and didn't provide a good infrastructure. Besides, saying that private property reduces the income and inequality gap is kind of absurd. It's true that developing countries like Brazil and South Africa are highly unequal, but in the US, for example, 1% of the richest people in the country make 139 times more money than the poorest part of the population. and there were more than 700,000 homeless people in 2024. Besides, 1% of the world's population is wealthier than the rest of humankind put together. If inclusive institutions were really that powerful in richer countries, then there wouldn't be more than 1 billion people living in acute poverty all over the world. There's no point in saying that private property makes everyone's lives better if people can't even afford to have a house in the first place. And using the GDP to calculate the wealth of a country is not exactly the best way to understand poverty, because the GDP only considers how much money the industry itself makes. It ignores, for example, the question of whether people who work in those industries have good jobs, if they are well paid and have a good life. The GDP also ignores inequality, which means it ignores those inclusive institutions we mentioned before. In the United States, there are about 835 billionaires, but 11% of the American population is still very poor. So, my hot take here is that inclusive institutions are not that inclusive, and that money is not that well distributed in the first place. Different cultures also have different concepts of what it means to be wealthy. In London, for example, being able to afford food, clothes, and shelter does not make you rich. To them, you're simply surviving. If you want to be truly wealthy in London, you might have to hire a housekeeper, buy a horse, and have a personal Pilates instructor. But to the Awa or the Yanomami tribes, money doesn't even exist. They produce only the necessary, and if they have a surplus, they will trade with other tribes. I guess the fact that poor countries are all located closer to the equator line is not just a simple historical coincidence.
Meet Hula Male, also known as the City of Hope. This nickname makes total sense since this artificial island is part of the Maldives' big plan to avoid being completely submerged in the near future. Hula Male was created by placing sand from the seafloor onto a submerged coral platform, and it worked. This city sits about 6 feet above sea level, which means it's twice as high as the Maldives' capital, Male. While more and more people are moving there to live, the island was also designed to serve as a temporary evacuation site during dangerous storms and typhoons. Seychelles is another gem in the Indian Ocean that's at risk of disappearing. Unfortunately, coastal flooding is becoming a common issue there, especially during spring tides and heavy rainfall. The problem is that their main island, Mahé, hosts about 90% of the country's population. Along the coast, it's only about 6 feet above sea level. Fiji is the third tropical paradise on our list, and it's also a top pick for travelers. But this nation is in a tough spot, since it's located right in the middle of the Pacific Ocean, where huge storms can really turn things into chaos. Take Cyclone Winston. It hit Fiji back in 2016 and ended up costing them over $1 billion in damage. So one thing they're doing to protect themselves is planting mangroves along the coast and preserving the ones that already exist. These trees are awesome since they help reduce wind speed during cyclone emergencies and also combat erosion by trapping sediments. Egypt might be in trouble too. I mean, it's not like the whole country is going to be underwater, and we'll only see the tips of the pyramids in a few years. But things could really change for them, as coastal cities are facing a serious risk. Take Alexandria, for instance. 45% of its population already lives below sea level. If the city is flooded, not only will everyone have to move, but Egypt in general will suffer a major impact on its fish production. In Europe, one of the most at-risk populations is in the Netherlands, where about half the people live in areas below sea level. In the future, planning a romantic gesture with tulips for your girlfriend could become an impossible mission. The Netherlands is responsible for 2/3 of the world's tulip production. So if fields are taken over by saltwater, it's game over for the blooms. But the good news is that the Dutch have centuries of experience dealing with water, so knowing how to work with storm barriers and seawalls can prevent them from a doomsday scenario. The risks of rising sea levels probably aren't higher anywhere else than here in Tuvalu.
This island chain, located halfway between Australia and Hawaii, could be the first state to become uninhabitable. Its stunning land is only about 9 feet above sea level. And just by looking at it on the map, you can see how narrow it is. In fact, the narrowest part in Fongafale is only about 65 feet wide. So even before higher tides become a real problem, the country's limited farmland could be flooded with salt water. The next country on our list is the Philippines. This archipelago in Southeast Asia boasts some of the most stunning scenery, but it faces the risk of flooding for 2 reasons. First, due to rising sea levels, and second, because of crazy, unpredictable weather. Since 1990, events like cyclones, earthquakes, and tsunamis have cost the country over $20 billion. Have you ever heard of Vanuatu? This chain of islands, spread out between Australia and Fiji, could be flooded soon. Vanuatu was one of the first Pacific nations to relocate an entire community to a safer spot. Back in 2005, residents living in risky coastal areas of the northern island of Tegua moved to higher ground. Next up, the Marshall Islands, a country located in the Central Pacific. Studies show that 40% of the buildings in the capital city, Majuro, could end up underwater in the future. But this country isn't throwing in the towel just yet. They've got a game plan. They are fortifying the infrastructures of their low-lying airport, relocating key buildings to higher ground, and putting up seawalls on rural islands. Heading south, we've got Nauru. This is actually one of the smallest countries in the world, covering just 8.1 square miles. Today, it's home to 10,000 people, but it's on the brink of becoming uninhabitable. Water levels are rising about 3 times faster there than the global average. The Buada Lagoon sparks special concern since it's the only surface freshwater resource, and it's located only 16 feet above sea level. Our next stop in the Pacific Ocean is the Republic of Palau. Rising sea levels are no joke for them either, but protecting their crops, especially taro, is a priority at this moment. About halfway between Hawaii and New Zealand lies Samoa, and this country is dealing with a unique situation. Not only is the volume of water increasing there, but their land is also sinking. You see, a couple of strong earthquakes and tsunamis hit Samoa back in 2009. So as the crust bounces back to its original position, the overall land surface is actually going down. Because of this, their housing and main infrastructure could take a serious hit, especially since all their airports are along the coast. Let's head to Kiribati. This Pacific nation has a big problem with frequent flooding because most of its people and infrastructure are near the coast. Apart from the volcanic island of Banaba, none of Kiribati's land is more than 6.5 feet above the ocean. To tackle this situation and keep their population safe, they had this big idea of making a massive floating platform, kind of like the ones oil companies have. But the problem is that it would cost them a fortune, as the project is estimated to be around $2 billion. If visiting Vietnam is on your bucket list, you better hurry up. The top 10 things to do there mostly involve cruising to jaw-dropping spots like down to Ha Long Bay, also known as the Descending Dragons Bay. But by 2050, the surrounding land over there might be underwater. Another huge problem Vietnam is facing is that the main rice fields are getting salty. And if you're into Vietnamese food, you know how important rice is for them. Right now, they're especially concerned about the Mekong Delta region being vulnerable. After all, this is a highly fertile area responsible for most of Vietnam's agricultural output, with over 50% of it being, rice. This nation is really putting in the effort to adjust to this new reality. They're flushing the rice fields in the Mekong Delta with fresh water to get rid of the saltiness. Our next stop is in the Caribbean Sea. Grenada is an island country, but you may know it as the Island of Spice, since its tropical climate is just perfect for cultivating things like nutmeg, cinnamon, cloves, and ginger. Unfortunately, Grenada and its incredible fertile soil also face an uncertain future of being submerged. Let's talk about the last country on our list, the Solomon Islands. 5 islands in this archipelago have already vanished beneath the waves, and 6 others are submerged by 20%. They include the Nusa Evili Island, which was once a hotspot to go to for a picnic in the early 2000s. Even though the situation is complicated, it's important to note that more than 300 of the islands there are inhabited. One thing about the Solomon Islands is that it seems like they're always in some kind of recovery mode, since the country often gets hit by tropical cyclones and flash floods. Their population is already working hard to save their homes from the rising seas by building stone walls along the coast, planting mangroves, and constructing houses in higher areas.
It all started out as an ordinary working day for Gary Johnson, who was driving his excavator at a quarry in Oxfordshire. He was clearing the clay when, all of a sudden, he hit a bump. It turned out to be a huge footprint, and no animal from today could have possibly left it. Then, Gary noticed another huge footprint, just 10 feet ahead, and then another one. He soon realized those could be dinosaur footprints. And he was right. There were a total of about 200 huge footprints from 166 million years ago, or the middle of the Jurassic area, crisscrossing the limestone floor. Scientists started digging at the location in June 2024. The longest trackways they found are around 500 feet long. It wasn't the first major discovery in the area. Back in 1997, they found 40 dinosaur tracks nearby while digging in a limestone quarry. This time, the team took 20,000 photos of the new prints and made 3D models using flying drones. In total, there were 5 pathways at that site. 4 of them were made by sauropods, which were huge plant-eating dinosaurs that walked on all 4 legs. Their footprints kind of look like giant elephant prints, only way bigger, because these dinos could grow up to 60 feet long, about 2 times as long as a London bus. The 5th track might have come from a megalosaurus, a carnivore. Its footprint looks like the kind you'd see in a cartoon. It's called a tridactyl, which means it has 3 big, clear toes. Hey, just like me. Kidding. Unlike previous dinos, these guys could walk and even run on there too. Back then, the area they lived in was like a warm, shallow lagoon, and these dinosaurs squished through the mud, leaving their footprints behind. The footprints can help us learn how fast the dinosaurs moved, how they walked, how big they were, and what kind of environment they lived in. You can't learn all that from bone fossil records, which makes this discovery super important. Scientists think that a big storm helped save the prints in such great condition. It could have dumped a lot of mud on top of them, keeping them safe from being washed away. Just several months after the Oxfordshire discovery, scientists found over 260 matching dinosaur footprints more than 3,700 miles apart on different continents, in Brazil and in Cameroon. When they studied these prints, they realized they were about the same age and shape and came from the same type of land and plate tectonic contexts. Northeastern Brazil and what is now Cameroon in Africa is one of the last tiny land bridges where dinos could cross between the landmasses freely before the continent of Gondwana broke away completely, around 120 million years ago. Africa and South America started drifting apart around 140 million years ago, and the South Atlantic Ocean slowly filled the gap between them. As the land split, big basins formed, and rivers and lakes began to fill them up. The footprints were found in those very basins, on both sides of the ocean. Most of the prints were made by 3-toed theropods, which were meat-eating dinosaurs. But there were also prints from sauropods and ornithischians, who were herbivores. The plants in those river valleys fed the plant eaters, which helped build a whole food chain. And the muddy ground helped preserve the dinosaurs' footprints, just like in England. The latest footprint discovery, this time in the Scottish Isle of Skye, helped scientists learn something new about the dino habits. So far, they've found more than 130 footprints at Prince Charles Point. And it turns out that huge meat-eating dinosaurs and their plant-eating prey shared the same water here 167 million years ago. Some of the tracks were made by megalosaurs, meat-eating dinosaurs that were early relatives of the T-Rex. Others were from huge long-necked plant-eaters. Some of them were 3 times bigger than an elephant. The scientists looked closely at the footprints to figure out how the dinosaurs walked and moved around. They believed the dinosaurs were hanging out near shallow freshwater lagoons, just like animals today gather around watering holes. Another important discovery from the Isle of Skye is 2 super rare fossils that are helping scientists rewrite the whole evolution of mammals. Some shrew-like creatures today live just around 1 or 2 years, right? Well, those little guys used to stick around for 7 years or even longer. Scientists found 2 nearly complete skeletons of it on Skye. One was a grown-up and the other was a young one. To figure out how these animals lived and grew, scientists used high-tech X-ray scans to look inside the rock and check the teeth, kind of like counting tree rings to find out how old the tree is. The younger creature was still changing to adult teeth, but was already about 2 years old, which is very unusual for small animals. It lived in the area during the Jurassic period, when Skye was warm, tropical, and full of shallow seas and thick forests. Back then, these tiny and strange early mammals were just starting to appear in a world ruled by dinosaurs. But they were the beginning of the long line of mammals that would one day include cats, whales, and humans. Scientists are learning about the final days of dinos from a new fossil site in Argentina. Most of what we know about the impact of that dramatic asteroid hit comes from North America, where T-Rex and Triceratops once lived. But now, we get to see what happened further south. The team of scientists working in a local quarry found bones from hadrosaurs, which are pretty rare in South America. Long ago, this desert area was warm and full of plants like ferns and palms. There was a stream flowing through wide, flat lands, which helped bury and preserve the animals that lived there. Back in 2020, scientists were exploring the area when a paleontologist found a dinosaur foot bone. They kept looking even through heavy rain and discovered a whole group of fossils, not just from one dino, but from several of different ages, maybe even a whole herd. Another super important discovery here was a tiny mammal jaw with 5 teeth found just 2 hours after searching the site. The jaw came from a small plant-eating mammal. These creatures were about the size of a chipmunk and had very special teeth with ridges and grooves for chewing plants. This was the first time a mammal jaw had ever been found in that whole area, and it made scientists realize the site could tell them more than just dinosaur stories. The team also found a tooth from another dinosaur and a claw from a smaller predator. All the fossils found here could help answer some big scientific questions, like were the dinosaurs already slowly disappearing before the asteroid hit, like they probably did up north? And what happened to the animals that survived the asteroid hit? Several years ago, scientists found another fossil, this time encased in amber, that came back from a time when dinosaurs walked the Earth. The world looked very different, but it also had some surprising things in common with today. Back then, the night skies were also lit up by glowing fireflies, and the dinos probably watched them like we do. The amber is 99 million years old, and this special firefly is only the second one ever found from the Mesozoic era. Finding these kinds of fossils is really hard, because fireflies have soft bodies that don't turn into fossils very well. That makes it tricky for scientists to figure out exactly how and when these beetles started to glow. But now, thanks to the newly found firefly, they believe the glowing started at least 100 million years ago. The fossil helps fill in the gaps in the evolution of fireflies and their ancestors. It shows that important parts, like their glowing bellies, have stayed the same since the middle of the Cretaceous period.
You could wake up in New York, grab a bagel for breakfast, hop on a train, and by lunchtime, you'd already be in London enjoying fish and chips. What sounds like every tourist's dream could be a reality soon. Right now, traveling between these two cities usually takes about 8 endless hours by plane. But a high-speed train zipping through a massive transatlantic tunnel could make the same journey in just 54 minutes. The plan is to construct this train beneath the Atlantic Ocean, so the stations would look like those trendy underwater restaurants. Not only would you get to Europe in record time, but you wouldn't have to deal with jet lag or feel sick from turbulence. So far, this mega project sounds amazing, but can we really pull this off? Well, that's the million-dollar question. Actually, it's more like a $20 trillion question. That's how much this train and its futuristic underwater stations would cost. It's hard to imagine anyone having enough money to construct it, so specialists thought it was out of the question. But people started feeling hopeful again when Elon Musk dropped this announcement. He said not only is this kind of transportation possible, but his company could make it happen for 1,000 times less than everyone thought. Traveling between New York and London in less than an hour means the train would have to hit a jaw-dropping speed of 3,000 miles per hour. Yep, 3,000. That's about 5 times faster than the cruising speed of a commercial airplane like a Boeing 747. So, how is this even possible? Well, it's not an average tunnel. We're talking about a vacuum-sealed tube underwater, which cuts out air resistance, letting trains zip through at insane speeds. And it's not just any train. It's more like a high-tech aerodynamic capsule that levitates and moves thanks to magnetic propulsion. At least that's what experts think, since this kind of technology is already in use today with the fastest public train in the world, the Shanghai Maglev. This machine runs in China and hits a top speed of 186 miles per hour. What's crazy is that its locomotives are not even touching the tracks. They're literally levitating and floating just about 0.4 inches above the ground. This line takes people from Shanghai to Pudong International Airport, so travelers don't have to worry about traffic and can get to their flights super fast. This cutting-edge technology makes a 19-mile trip take just 8 minutes and 10 seconds. With a regular train, that same journey would be about 4 times longer. Back in 2001, people worked hard over 2 years to construct the maglev train, and they also spent a lot of money, as the whole project cost over $1 billion. Despite that crazy initial price tag, keeping this line running is not as expensive as it might seem. It's actually cheaper to operate than regular trains. Since the maglev doesn't touch the tracks, that means a lot less wear and tear and way lower maintenance costs. On top of that, its propulsion system is impressively energy efficient. As we've already mentioned, this is the fastest operational train in the world, but China isn't stopping there. They're likely to break their own record soon, having already unveiled a prototype of their next-generation train, the CR450. This sleek silver bullet had reached test speeds as high as 281 miles. If this project comes to life, if people really start using it on a daily basis, it will be a game changer for high-speed rail. And it could shrink the journey between Beijing and Shanghai to less than 3 hours. That's like 1 hour less than what people take when traveling on today's high-speed train. Now, the team just needs to run a couple more tests to ensure it meets all necessary standards for commercial operations. This car looks like a Batmobile, and it's probably just as powerful. Say hello to the amazing Koenigsegg Jesko Absolute. Its sleek, futuristic design isn't just for show. Every detail on this machine was crafted to cut through air with precision, reducing drag and turbulence while boosting its high-speed performance. Experts ran the first computer simulations, and the Jesko Absolute hit an astonishing 311 miles per hour. But the team is positive that it can go even faster. This beast comes close to the cruising speed of small jets, and because of that, it smashed all records and became the fastest car in the world. When you visit the Coventry Transport Museum in England, you'll come face to face with a terrestrial vehicle that looks more like a rocket than a car. Meet the Bloodhound LSR. It's been on display since 2019, right after hitting 628 miles per hour during tests in South Africa's Kalahari Desert. But the team behind this vehicle isn't satisfied just yet, and they're 99% sure they can go even faster. So, they're planning to bring it back to the track soon, aiming to smash another record. But there's a catch. The team is still looking for a fearless, skilled pilot who can handle speeds over 800 miles per hour. And before you rush to sign up for the challenge, let me remind you, it's going to take more than just guts. You will need a major sponsorship deal too, because getting back this vehicle on the track and breaking that land speed record could cost around $15 million. If you're curious about the fastest jets in the world, look no further. Meet the North American X-15, a legendary aircraft that flew for nearly 10 years and set an unofficial world speed record of 4,520 miles per hour. This beast is so impressive that it actually reached the edge of space during its test flights in the 1960s. Yep, astronauts territory. To put that into perspective, commercial airplanes, like the ones we fly in, usually travel at altitudes of up to 42,000 feet, but the X-15 soared more than 354,000 feet. Now, imagine flying faster than ever before, zooming through the sky at over 5 times the speed of sound. That's exactly what NASA did with this revolutionary aircraft, known as the X-43A. This airplane is scramjet powered, which basically means it's an engine that operates at a supersonic level. I mean, it doesn't have any moving parts like regular jet engines do, like turbines. Instead, it uses the plane's speed to push air into the engine. The air gets compressed or squished by the plane's fast motion, then mixed with fuel and burned to produce thrust. For non-experts, this might seem crazy, even dangerous. In fact, we should mention that the first flights of the X-43A weren't exactly smooth sailing. The initial attempt happened back in June of 2001, but the airplane was destroyed after the booster rocket went out of control. Thankfully, the second and third attempts were a huge success, with record-breaking flights that made history. I know elevators aren't the first thing that comes to mind when we think about super-fast means of transportation, but it's only thanks to ultra-modern high-speed elevators that skyscrapers as tall as the Burj Khalifa and Taipei 101 became accessible. One of the fastest elevators in the world is located in the Shanghai Tower in China, which has 128 floors. To get people from the ground floor to the top of the building quickly, the elevator has to move at an incredible speed of 67 feet per second. That's faster than Usain Bolt at his top speed, but just a little slower than a cheetah. Still, it is super fast, about 5 times quicker than the elevators we ride in most buildings. So if you're afraid of heights, speed, and tight spaces, we suggest you avoid going that far.
Surprise! There's more than 7 continents on our planet. Argoland, a hidden continent, may help us understand how our planet will look in the future. To find out how it hid from us and what secrets it holds, well, you'll just have to keep watching. Ready for a mystery? Scientists have been looking for a piece of land that's been missing for over 100 million years. Not exactly newsworthy, since people search for information about our planet's history all the time. You'd think it was probably this minuscule island somewhere in the middle of an ocean. Well, you'd be wrong, because this continent used to be as big as the entire U.S. territory. For a long time, geologists have been wondering whether a massive chunk of contemporary Australia vanished into thin air. Some believed it was simply hiding somewhere on the ocean floor. But thanks to some Dutch specialists and 7 years of investigating, we now know there are bits and pieces of this lost land mixed underneath the lush jungles of Southeast Asia. The continents we see in our geography manuals these days are like scattered pieces of a puzzle. There's even a nice experiment you can conduct to see for yourself. Find a world map online and print it out. Cut out all of the continents and play around with them for a while. You'll see they all fit together. Probably the most striking thing you'll see is how South America perfectly fits near Africa. If you close up the oceans that were formed in the last 200 million years, the continents look like they form a giant letter C. And that C is what scientists call the supercontinent Pangaea. It was swimming in an ocean called Panthalassa, and the inner portion of that letter C had a smaller stretch of water called the Tethys Ocean. It is in this small ocean where things get interesting. Back in the Jurassic period, this vanished continent, which scientists started calling Argoland, vanished and left a hole in Australia, now known as the Argo-Abyssal Plain. Geologists initially believed this was all due to a process called subduction. It's when one piece of the Earth's crust dives under another and recycles it into the planet's mantle. Usually, specialists track this continental vanishing through off-scraping. That's how they figured out, for instance, that India bumped into Asia and gave us the majestic Himalayan mountains. But for Argoland, things were a bit more complicated. Bits and pieces were popping up in places like Myanmar and Indonesia, but they behaved like these time-traveling relics, looking way older than when Argoland supposedly separated from Australia. It immediately raised the question, if one continent can behave so weirdly, how many others are out there doing the same? Thankfully, scientists have now put together the entire timeline of Argoland and figured out its mystery. It didn't sink or get swallowed up. It simply transformed into an archipelago, breaking into smaller pieces, called microcontinents, and floating away from Australia. These mini-continents then took a little journey before settling down in Southeast Asian jungles. This discovery fits right into the whole Pangaea puzzle. It helps us better understand how continents break up and make up, all in one discovery, revealing secrets of biodiversity and climate back from in the day. If you'd like to find out more secrets about history, civilization, or random day-to-day objects, be sure to like this video and subscribe to the channel. Like, for instance, the mystery behind this invisible species line in Indonesia. It's called the Wallace Line, named after the British explorer Alfred Russel Wallace. Over 150 years ago, Wallace was on a journey around the Malay archipelago, visiting thousands of islands. What he found was that animals on one side of this invisible line were considerably different from ones on the other side. This invisible line is like a wall between marsupials and tigers, for instance, or honey-eaters and trogons. But now we know that around 35 million years ago, Australia broke up with Antarctica and collided with Asia, and this continental love triangle triggered significant changes. It didn't just change the way the land looked, it also messed with the species of animals on each side of the Wallace Line. In more recent times, a bunch of specialists published a study saying this collision and climate chaos made Asian species comfy living in the Malay archipelago. Meanwhile, the Aussie animals weren't as happy with the new environment. It was too hot and wet for some, and others just couldn't handle the tropical island lifestyle. The discovery of this continental shift towards Asia might also explain a recent finding of a human species that didn't seem to make any sense either. You see, in this hidden cave in the Philippines, archaeologists stumbled upon a new human ancestor. It seems that about 50,000 years ago, on the island of Luzon, there was this ancient human-like species. The lead researcher believed this finding was crucial for understanding human evolution in Asia, and it named this new species after the island, Homo luzonensis. Now, here's where it gets a bit confusing. The bones found by archaeologists had one small problem. They had a weird mix of traits that hadn't been seen together in any other hominid species. Smaller teeth, similar to ours, yet hands and feet that were more like our ancient humanoid ancestors. It was those throwback limbs in particular that connected this human species with the long-lost Southern Territory. That's because they have this primitive look, like these hard-to-pronounce guys, for instance. Only these two species are separated by 2 to 3 million years of time in evolution. Many have wondered, is Homo luzonensis really a new species? Not everyone is convinced. But it may also explain why living creatures are also affected by the constant shifting of the land underneath us. Now, just because they haven't changed much during our lifetime, it doesn't mean our continents will look like this forever. They evolved from this large megacontinent, and they'll most likely end up in a similar position in the future. On that note, a geologist from a European university tried to predict the future of Earth's supercontinents. As a starting point, he used an earthquake that occurred in Portugal back in 1755, when tectonic plates behaved a bit differently than they should have. After years of research, he came up with a theory in 2016. He believed that the stitches between these tectonic plates might be coming apart, setting the stage for a bigger rupture. It's like when glass cracks between two holes in a car windshield. If this happens, a subduction zone could stretch from the Mediterranean all the way up past Ireland, bringing volcanoes, earthquakes, and new mountains to these areas. If all goes according to this plan, the Atlantic Ocean will disappear, and so will the Pacific, turning into one large stretch of water. Instead of the 7 continents we know today, we'll get a new supercontinent, which he called Arica, because it would have Australia and the Americas at its heart. Now, it's not the only possible scenario, though. Novo Pangea might be another, and it's easy to foresee. The Atlantic stays open and the Pacific closes. Then there's Amasia. For this one, you'd have to imagine the Arctic Ocean closing and the Atlantic and Pacific staying open. Everything shifts to the north around the North Pole, except Antarctica. One final scenario would be called Pangea Ultima. Slow down the spreading in the Atlantic, and a new subduction plate pops up on the America's east coast. Well, either way, if all the continents collide in the future once more, some say it won't be fun to experience. It's believed that in around 250 million years, we'll feel like we're being trapped in a sweltering, soggy plastic bag. Weirdly, that bag will be the best place to live on Earth, the coastal areas. As for the inland spots, they'll be sizzling, like a desert on fire. Many of the species of animals we know today might not make it. As for us humans, we'll need to be creative if we want to withstand the heat. We should be thankful, though. These digital models are still great because we can use them to test all sorts of interesting ideas. For example, how these supercontinents would mess with tides. Taking future space travels into consideration, these models can help us understand the climates of exoplanets too. Those are located outside our solar system.
The world's largest fence spans over 3,100 miles from Queensland to South Australia. If stretched out, it could easily connect London to New York. And if you'd walk next to it, you'd need 6 months to complete the journey. It wasn't built to safeguard the Australian border. Why would it, since Aussies are just surrounded by water? It wasn't meant to protect some important building either. Its purpose is to keep some animal species away from each other. It was back in the late 1800s when Australians started building parts of this fence. They wanted to create a barrier separating the lively, bustling part of the country where cities like Melbourne and Sydney thrive from the harsh, dry outback. They used wooden posts dug deep into the ground, linked up with wire mesh standing about 6 feet tall. Some parts of the fence even have a second electrically charged layer. To make sure this fence did its job, they added some red and white lights to help guard things even at night. A team of over 20 people work full-time to keep things in check here. And every year, local authorities chip in around $750,000 to keep the construction in shape. Why all this trouble? The main reason was dingoes. These gingery, wolf-like creatures are Australia's largest carnivore mammals, and they're also apex predators. They were causing a lot of trouble to local farmers, especially in southern Queensland, where they often go after sheep. For the most part, the fence has been doing its job okay, but it's not foolproof. Some dingoes still manage to sneak through. Other times, wild camels end up crashing into it. That's because Australia has quite a massive camel population roaming around. But this man-made solution did more than locals expected. They thought there would just be fewer dingoes within the fence, but fewer dingoes mean more kangaroos. And more kangaroos mean more competition with the sheep for food. It's not just the bigger species feeling the squeeze. The smaller animals and the greenery also went through changes. With all this competition in a smaller space, locals noticed less diversity in the plant life and small animals. The soil became less nutritious over time, affecting plant growth. Plus, the fence acts as a roadblock for animal migration and seed dispersal. Even the sand dunes are feeling the effects, with less grass cover to hold things together. When scientists looked at kangaroos on both sides of the fence, they noticed that the young pups inside were lighter and tinier on average. The outsiders had bigger feet and heads for their age, and it wasn't because they were eating a different diet. The kangaroos that were stuck sharing the land with dingoes had to bulk up faster to survive. On the flip side, those inside the fence took it slower because they weren't under the same type of pressure. These had to compete with a lot of other creatures for food, so a bigger size wasn't a priority anymore. Researchers are still not sure if this difference is a quick fix or a long-term gene adaptation. What about domesticating dingoes? Wouldn't that help? Many think dingoes were once pets in Australia, but it's not known for sure. These days, they're pretty wild, just like wolves, hyenas, or coyotes. Most of them don't need packs to survive and are solitary hunters with sharp instincts built in. So taming them isn't going to be easy. Still, taking down the construction is not an option for now. Australians are so strict when it comes to making sure dingoes are kept away that they even put laws in place for people who mess up with the fence. Leaving a crossing gate open can put people behind bars for up to 3 months. Damaging the fence can cost people 6 months' worth of their freedom. It wasn't the first time Australians thought a fence could help with animal issues. Before they needed it for dingoes, they experienced a serious bunny invasion. Cute as they are, rabbits were damaging the land used for farming, so locals thought of a 3-part fence. The first one stretched all the way from Ravensthorpe in the south to Pardue Station on the Pilbara coast. It was over 1,100 miles long, making it the longest unbroken fence globally at the time. All these bunny problems could have been traced back to a man named Thomas Austin. Back in 1859, when he first came to the land down under, he thought it would be a good idea to release a few rabbits into the wild, thinking it would add a bit of charm to the place. But since rabbits aren't native to Australia, they didn't have any natural predators at the time. They're also pretty adaptive creatures, needing just some grass for feeding. They reproduce at astonishing speeds too. A mama rabbit can have 4 litters a year, with as many as 5 bunnies each. Pretty soon, their numbers boomed. By the late 1880s, the bunnies had caused so much damage that local authorities came up with a proposal. They'd offer the equivalent of almost $2 million today to anyone who could come up with a solution to this long-eared problem. Nobody claimed the prize, but a commission did gather a bit over a decade later and came up with the fence idea. Maintaining those fences was complicated. They had inspectors keeping an eye, with each one responsible for a stretch about 500 miles long. There were also these boundary riders patrolling smaller sections, using bikes at first, then switching to camels or using camels to haul buggies. They even tried using cars at one point, but they couldn't handle the rough terrain and constantly had punctured tires. In terms of its effectiveness, well, by 1902, rabbits were already hanging out on the wrong side of the fence. That's why, 4 years later, they put up another one. It worked for a while, so much so that the local authorities didn't bother helping out farmers past that second fence with rabbit netting loans. Those caught between the two fences, however, still had a rough time dealing with rabbit trouble. Soon enough, rabbits spread even over fence number 2, and it was clear the solution didn't work. In some areas, even while the fences were being built, those sneaky bunnies found their way past them. To this day, the rabbit population still sometimes puts the Australian officials through rough times. The dingo fence may be the longest one, but it's not the weirdest. The aquarium fence in Turkey might take that prize. This 164-foot aquarium fence was built to make sure the expensive villa's ocean view would be visible from every one of its levels. These days, it gathers a lot of tourists from all over the world, eager to see the variety of fish it contains, and even the octopuses. Putting up a see-through structure wasn't hard. The real challenge was connecting the aquafence to the Aegean Sea through a buried pipeline stretching across 13,000 feet of land. This ensures water constantly flows, keeping the aquarium clean and the fish happy. To make sure no one damages the delicate fence or steals any of the fish or two, the owner also invested in security. He installed a network of 17 cameras equipped with facial recognition. Visitors are free to look and take pictures, but step too close and you're likely to trigger alarms. Another one of those weird fences is New Zealand's bra fence. If you ever find yourself through central Otago, you might stumble upon a fence adorned with bras of all kinds of shapes, sizes, and patterns. Its story takes us back to 1999, when people in the area found 4 bras mysteriously hanging on the fence near Cardrona Valley Road. Some were a bit surprised, but then others started adding their bras to the decor. Some more bras appeared and it became a must-see spot for tourists. Its popularity was so high that at times it caused traffic problems in the area.
While you're watching this video, pieces of continents are slowly breaking off from below and are pulled down into the oceanic mantle, a hot, mostly solid layer that moves slowly under the seafloor. As soon as these fragments reach the mantle, they can trigger volcanic eruptions in parts of the ocean where there are no volcanoes. Plus, when continents break apart, it happens not only at the surface, but also deep down. But more on that later. This process can continue for tens of millions of years. The new study shows that Earth's insides are even more dynamic than we thought. It also explains why many volcanic islands, including Christmas Island in the Northeast Indian Ocean, contain unusually high levels of certain chemical elements. The thing is, these elements are normally only found in continental crust. Well, scientists did suspect that these elements showed up because some powerful forces deep inside the Earth took old, recycled pieces of rock and mixed them into the mantle. This process works a bit like when you mix together ingredients for cake batter. But before, researchers believed those elements came from 2 main sources: sediment that sank into the mantle as oceanic plates got pushed down, or from mantle plumes. Those are columns of hot rock rising up from deep inside Earth. However, these explanations don't fit all observations. In some volcanic areas, there's almost no sign that the crust has been recycled. In other places, the mantle seems to cool and too close to the surface to be affected by the rising hot rock. Scientists used to wonder how this could happen. Now we know that some of the material in those regions comes from pieces of continents that sink deep into the mantle, and these pieces affect the volcanoes that form above. The new study also suggests a curious idea. Continents don't just break apart at the surface, they peel away from below too. And this can happen over much greater distances than scientists thought before. Researchers used simulations to figure out how continents and the mantle behaved when stretched by tectonic forces. Their work is built on earlier research showing that when continents split, deep, powerful forces inside our planet create a mantle wave. This wave moves along the base of the continent at depths of about 90 to 125 miles. The wave moves extremely slowly, about 1/millionth of the speed of a snail, and gradually strips material from the roots of the continents. These peeled-off fragments are then carried sideways, sometimes more than 620 miles, into the oceanic mantle. Once there, they can trigger volcanic eruptions in the ocean for tens of millions of years. The research also shows that the mantle continues to feel effects of continental breakup long after the continents themselves have separated. Even after a new ocean basin forms, the mantle keeps moving, reorganizing and transporting enriched material far from where it originally came. To make this conclusion, researchers studied geochemical data from different parts of the Earth, including the Indian Ocean Seamount Province. That's a chain of volcanic formations that appeared after the supercontinent Gondwana had broken apart over 100 million years ago. Their computer models and chemical tests showed that right after the supercontinent Gondwana broke apart, a lot of magma with unusual chemicals pushed up to the surface. Over millions of years, this chemical signature slowly faded as less material came up from under the continent. The most unexpected discovery is that this happened without any help from those deep, hot columns of rock scientists used to think were needed. Now, to get an even clearer picture, let's sneak a peek into our planet's insides. Earth is about 4.6 billion years old. It was born from a huge cloud of dust and gas that slowly cooled, shrank, and hardened into the planet we know today. As it cooled, heavy metals like iron and nickel sank to the center, and lighter, rocky materials floated upward. This created the Earth's layered structure, with each layer having its own unique properties. The crust is like Earth's skin. It's our planet's outermost layer made of solid rock. It's broken into huge pieces called tectonic plates that slowly drift over time. There are two kinds of crust: oceanic crust and continental crust. The oceanic crust is about 4 to 6 miles thick. It's covered with a thin layer of sediments like sand, clay, and shells. Below that are dense rocks like basalt, rich in magnesium. As for the continental crust, it's thicker than oceanic crust and is located under continents. It's made of lighter rocks than oceanic crust. Beneath the crust is the mantle. It makes up more than 75% of Earth's volume. The top of the mantle is pretty rigid, but deeper down it becomes soft and partially molten, which allows it to flow slowly. This flow is what moves the tectonic plates. At the center of the Earth lies the core. It's made mostly of iron and nickel and has two distinct layers, the outer core and the inner core. The outer core is a liquid layer of iron and nickel. It's insanely hot, up to 10,800 degrees Fahrenheit, as hot as the surface of the sun. The outer core also generates Earth's magnetic field, which protects us from harmful solar radiation. The inner core is solid because of the crushing pressure inside the planet. It's also made of iron and nickel. Now, the Earth's outer shell, called the lithosphere, is made up of the crust and the uppermost part of the mantle. It's broken into large pieces, called tectonic plates. There are a few super large plates and many smaller ones. 6 of the major plates are named after the continents they carry, like the North American, African, and Antarctic plates. But even those smaller plates play an important role. For example, the tiny Juan de Fuca plate is responsible for many of the volcanoes in the Pacific Northwest of the United States. The plates are moving like a jumble of old conveyor belts. They move very slowly, about 1 to 2 inches per year. But over millions of years, this movement shapes the face of our planet. Most earthquakes, volcanoes, and mountain building happen where plates meet, pull apart, or slide past each other. There are 3 main types of plate boundaries: convergent, when plates move toward each other; divergent, when plates move apart; and transform. That's when plates slide sideways past each other. When tectonic plates collide, the crust crumples and buckles, forming mountain ranges. About 55 million years ago, India crashed into Asia, slowly creating the Himalayas, the tallest mountains on Earth. The collision continues today, so the mountains are still rising. Mount Everest, the highest point on Earth, may even grow a tiny bit taller over time. At some convergent boundaries, an oceanic plate dives under a land plate in a process called subduction. The land above lifts up, forming mountains, and the sinking plate melts and triggers volcanic eruptions. This is how some mountains in the Andes of South America were formed. When 2 oceanic plates collide, one usually slides beneath the other, creating deep ocean trenches, like the Mariana Trench in the North Pacific, the deepest point on Earth. These collisions can also form underwater volcanoes that eventually rise above the ocean and turn into island chains, such as Japan. At divergent boundaries, tectonic plates move away from each other. In the oceans, magma from deep in the mantle rises to fill the gap. This creates underwater mountains and volcanoes along the seam. This process renews the ocean floor and slowly widens the ocean basins. By the way, a single mid-ocean ridge system connects all the world's oceans, making it the longest mountain range on Earth. On land, when plates pull apart, they form giant valleys, such as the Great Rift Valley in Africa. If this stretching continues over millions of years, East Africa could split off to become a new landmass. One famous example of transform boundaries is the San Andreas Fault in California. Unlike convergent or divergent boundaries, transform boundaries usually don't create mountains or oceans, but the grinding motion can cause powerful earthquakes, such as the 1906 earthquake that destroyed much of San Francisco.
Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangaea, or Pangaea if you're feeling fancy. The name comes from a Greek word which means all the Earth. Pangaea also had a massive water neighbor called Panthalassa. So our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things changed. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangaea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangaea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So how do we know Pangaea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learned their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their four paws. And it's unlikely that this particular type of animal originated in two places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were two original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figure out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangaea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangaea, Pangaea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangaea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangaea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So, if these secret tunnels will be spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangaea is the most likely scenario. It also depends on what exactly happened to Pangaea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday, our descendants will look at the world map and see this incredible journey come full circle. So, keep asking curious questions and stay tuned for the next 100 million years.
If you had landed on Earth a really long time ago, about 1.5 billion years in the past, you wouldn't have recognized our planet. At that time, all the land was stuck together in one giant supercontinent called Nuna, which was surrounded by an endless ocean. But if you had stuck around, you would have witnessed a planetary-scale disaster, Nuna falling apart. But the most amazing thing is that apparently, when Nuna started breaking apart, it kicked off changes that made Earth a much better place for life. Scientists used to call this part of Earth's history the Boring Billion. It lasted from about 1.8 billion to 800 million years ago. Not much seemed to happen during that time, hence the name. No big climate changes, no bizarre life forms, and nothing very dramatic. Turns out the name isn't very fair. Things may have looked calm on the surface, but underneath, Earth was changing a lot. Continents were moving, splitting apart, and coming back together. Two massive supercontinents, Nuna and later Rodinia, formed and broke up during this time. When Nuna began to break apart, huge cracks opened between the drifting land pieces. Water filled those spaces, creating shallow seas. Those seas were warmer, calmer, and had more oxygen than the deep oceans that existed before. And that might have changed everything. The new seas created friendlier conditions for life to grow and change. Scientists now think they may have helped early life become more complex. They looked back 1.8 billion years and rebuilt how Earth's tectonic plates moved over time. Plus, they tracked how carbon was stored inside the planet and released into the air. The researchers did this using a new advanced computer model that gave way more detail than they had ever had before. They found out that during the 350 million years of the so-called Boring Billion, the amount of shallow seas along the edges of continents doubled. Altogether, these coastlines stretched about 81,000 miles. That's more than 3 times around Earth at the equator. At the same time, subduction zones, places where one tectonic plate slides under another, actually got shorter as the continents shifted around. This is important because subduction zones are where a lot of volcanoes come from. When one plate sinks under another, seawater gets dragged deep into the Earth. That water helps rocks melt, creating magma. The magma rises, erupts as volcanoes, and releases gases like carbon dioxide into the atmosphere. So when there were fewer subduction zones, there were fewer volcanoes, and less carbon dioxide was pumped into the air. It went like this. The supercontinent Nuna broke apart, and it created lots of brand new ocean floors in young seas that didn't exist before. These new ocean floors pulled carbon dioxide out of the air. Seawater flowed into cracks in the ocean floor. When that happened, carbon got trapped in rocks, forming limestone. Over time, this process locked carbon away inside Earth instead of letting it stay in the atmosphere. With less carbon dioxide, Earth slowly cooled down. That cooler climate helped the new shallow seas become stable and rich in oxygen. Such calm, oxygen-filled environments are perfect for life to become more complex. Those huge shallow seas near the continents acted like safe nurseries for early life. They may have helped eukaryotes evolve faster. Eukaryotes are living things with complex cells. Cells that have parts inside them, like a nucleus that holds DNA. Every animal, plant, and fungus on Earth comes from these kinds of cells. So when eukaryotes appeared, it was a huge moment in the history of life. Scientists already knew that eukaryotes showed up during the Boring Billion because of fossils that are about 1 billion years old, but they didn't really know why this happened at that time. Now scientists want to find better preserved early eukaryote fossils to learn exactly how complex life first evolved. Life on Earth started over 3 billion years ago. It began with tiny, simple microbes and slowly turned into a huge variety of living things. We still don't have a clear answer about how living things came out of that early primordial soup, But even though there's no final answer yet, scientists have come up with several theories to try to explain how life on Earth may have started. Some scientists think lightning helped start life on Earth. The idea is pretty simple. Lightning is a powerful spark, and sparks can cause chemical reactions. In a famous experiment from 1952, scientists showed that electric sparks could turn simple gases like water vapor and methane into amino acids and sugars, which are basic building blocks of life. This suggested that lightning in early Earth storms might have helped create the first life ingredients. But later research showed Earth's early air wasn't exactly like the experiment. Still, some scientists think volcanic clouds could have had the right gases and lots of lightning, making this process possible. Other experts think life may have started on clay. One researcher suggested that tiny clay crystals could grow and stick together in patterns. As they did, they could trap simple molecules and line them up in organized ways. Think of clay as a kind of early organizer. Today, DNA tells molecules how to line up and work together. But what if clay had been doing a similar job before DNA even existed? It could be helping molecules arrange themselves until they eventually learned to organize on their own. This idea was interesting and got a lot of attention, but most scientists don't fully accept it yet. Another popular theory is that life started at deep-sea vents on the ocean floor. These vents are cracks in Earth's crust where super hot water shoots out from deep inside the planet. As the water rises, it picks up important chemicals like carbon and hydrogen, which are key ingredients for life. The vents are full of tiny rock spaces where these chemicals could collect, mix, and react. The rocks may have helped speed up these reactions. Even today, deep-sea vents house rich ecosystems, even though it's dark there and the whole environment is kinda extreme. Scientists are still studying this idea. In 2019, researchers even created early life-like structures in lab conditions similar to these vents. Such an experiment showed that this theory could really work. Another idea is that life may have started under ice. Scientists believe Earth's oceans might have been covered in ice around 3 billion years ago. Sounds pretty severe, right? But the cold may have actually helped life get started. Many of the chemical building blocks of life, like simple amino acids, are more stable at low temperatures. In warmer water, these molecules break down quickly and are spread far apart. But when water freezes, it pushes those molecules together, increasing their concentration. This crowding makes chemical reactions more likely. So, let's say the molecules were packed closer together and were breaking down more slowly. In this case, they had more chances to link up and form more complex structures. Ice may have also acted like a protective blanket. It could shield the water from harmful ultraviolet radiation from the sun and from damage caused by meteor impacts. Another idea is that life didn't start on Earth at all. This theory is called panspermia, and it suggests that life came from space. Scientists know that big asteroid impacts can blast rocks off of planets. For example, rocks from Mars have been knocked into space before, and some of them ended up on Earth. Some researchers think tiny microbes might have survived inside space rocks during the journey. If that's true, life here could have started thanks to visitors from Mars, or some other cosmic world. Others go even further and suggest that life could have traveled on comets or space dust from completely different star systems, hitching a ride across the galaxy. At the same time, even if panspermia is real, it doesn't fully solve the mystery. It just moves the question somewhere else. Instead of asking how life began on Earth, we'd need to ask, how did life begin anywhere in the universe? It's one of America's strangest contradictions. The Northeast, the cradle of cities, commerce, and crowds, hides a vast, empty wilderness at its northern edge. Millions live packed together to the south, yet up here, there's space for everyone, and almost no one takes it. How did this happen? How did the heart of America's most crowded region end up with one of its loneliest frontiers? The northeastern United States is home to more than 50 million people. It's one of the busiest and most densely packed regions in all of America. But almost 90% of those people live in the southern half of it. If you go north, past big cities and highways, everything will change. The noise will fade and the lights will thin out. You'll find yourself in a different world. A quiet land of forests, lakes, and mountains, stretching across northern New York, Vermont, New Hampshire, and Maine. This is America's empty Northeast. And the mystery is simple. Why is this part of one of the most crowded regions in the country so empty? First of all, let's take a look at New England itself. Massachusetts and Rhode Island are bursting at the seams, while Maine, Vermont, and New Hampshire feel wide open. Connecticut sits in the middle, literally and figuratively. Massachusetts is basically the crowd magnet. Most people live around Boston and the cities nearby, Cambridge, Worcester, Springfield, where everything's close, busy, and built up. Rhode Island may be tiny, but it's got a big city density. Connecticut sits right between Boston and New York, and it shows. It has a busy coastline and quieter inland towns. It's not too crowded and not too empty. The middle ground. Once you cross into New Hampshire, things slow down. There's Manchester and Nashua, but most of the state is forests, lakes, and open land. Then there's Vermont, easily the least crowded region of the bunch. The Green Mountains slice through the middle, and most people live in small towns or villages. And Maine is huge and mostly empty. Most people stick to the southern coast. If you head north, you'll hit endless forests, lakes, and long, quiet roads. It's beautiful, but it feels like the edge of the map. Today, the northern half of the Northeast, northern New York, Vermont, New Hampshire, and Maine, holds only about 4.9 million people. That's roughly the same as the population of the Boston metro area alone. To put that in perspective, if you take southern New York and southern New England, about the same land area, you get 10 times as many people living there. So, why the gap? It all comes back to geography, history, and economics, and how they've always worked together to keep the North empty. Let's start with the land itself. The thing is, the farther north you go, the rougher the land gets. Southern New England and downstate New York are full of rolling hills, wide valleys, and coastal plains. But then come the mountains. They're old, crumbling, and wild. In northern New York, you'll see the Adirondacks. To their east, the Green Mountains run up the middle of Vermont, stretching into Quebec. Keep going and you hit the White Mountains of New Hampshire. They're home to Mount Washington, famous for some of the most severe weather on Earth. And beyond that, the western Maine Mountains roll on toward Canada. Those aren't gentle hills, they're real barriers, and they owe their shape to one of the most powerful forces in Earth's history: ice. During the last ice age, huge glaciers covered this land. When they finally retreated, they carved out deep valleys and left behind thin, rocky soil. Later, the basins filled with water, creating thousands of lakes and ponds. It's a beautiful but difficult land to live on. Farming never stood a chance here the way it did farther south, where the soil is way richer. So the mountains stayed wild, covered in dense forests that even today stretch for miles. Northern Maine and the Adirondacks together make up one of the largest continuous forests east of the Mississippi. For centuries, people have come here to cut timber, fish, or hunt, but never in great numbers. And then there's the weather. Up here, winters are long, dark, and cold. Snow piles up early and doesn't leave easily. Summers are short, and the growing season is barely long enough to farm. It's not exactly a place that says, "Come start a new life." But of course, some people did. And here's where history comes into play. Long before Europeans arrived, this land was home to indigenous nations. The Abenaki, living across Vermont, New Hampshire, and Maine, had complex trade routes, connecting their communities all the way from modern Quebec to Massachusetts. Farther west, the powerful Iroquois Confederacy extended its influence toward the Adirondacks, controlling vast hunting grounds and trade routes. Then came the Europeans. In the 1600s, French explorers and fur traders pushed south from Quebec. They set up outposts along rivers and lakes that linked the region to Canada. They saw opportunity. Furs, fish, timber, but not farmland. The dense forests and harsh winters kept settlements small and scattered. The English, expanding north from the Massachusetts Bay Colony, took to the coast. They settled in southern Maine and New Hampshire, but going inland was another story. Between the cold, the forests, and the resistance from native nations, their progress was slow and dangerous. For more than a century, the interior of the northern Northeast stayed wild. Later, around the 1760s, the British took control of the region. Land speculators moved in, especially in Vermont, which both New York and New Hampshire claimed as their own. The overlapping claims led to chaos, and eventually, Vermont declared itself an independent republic in 1777. For 14 years, it existed on its own until it joined the United States in 1791 as the 14th state. New Hampshire pushed inland from the coast, building towns in the valleys between its granite mountains. Maine, meanwhile, spent centuries as parts of Massachusetts. Its economy ran on timber and shipbuilding. Trees turned into masts and planks for the growing British and later American navies. And in northern New York, the Adirondacks remained a wild frontier long after the rest of the state filled up. The land was too rugged and the winters too fierce. Logging, mining, and later tourism would bring people north, but never in huge numbers. By the mid-1800s, the southern parts of New England were booming. Cities were growing, factories were humming, and immigrants were arriving in large numbers. But the northern regions stayed quiet. So as we now know, the mountains are the first big barrier. They make everything harder: travel, building, farming, and surviving winter. The soil is thin, rocky, and poor. And what's underneath isn't much better. The region doesn't have rich mineral deposits or coal seams like the Appalachians farther south. Without valuable resources to mine or easy land to farm, there wasn't much reason for settlers to stay. That was one of the reasons why the economy never took off. The empty Northeast never became a center of industry. Southern New England had rivers that powered early factories, ports connected it to global trade, and the cities attracted millions of immigrants. Northern New England and northern New York had none of that. They had lumber, granite, and paper mills, all useful, but those industries didn't create huge cities. Even today, the economy up there relies on the same resources, along with tourism. People come to hike, ski, fish, and escape city life, but most don't stay year-round. Towns fill up in summer and fall, then empty out when the snow starts falling. A few small cities, Portland, Burlington, Manchester, thrive, but there's no Boston or New York up here. You won't find massive universities, corporate headquarters, or international airports to pull in young people and families. In fact, some states have gone so far as to pay people to move there. Maine and Vermont have both launched programs offering money to remote workers who relocate. That's a pretty desperate attempt to reverse decades of population decline. Today, this empty Northeast holds just about 1% of America's population. It's a land of deep woods, icy lakes, and quiet towns. The wilderness never really left this region, but that stillness is also what makes this place so special. The rest of the Northeast is filled with constant noise and motion. Meanwhile, the North is a reminder of what the region once was: wild, cold, and untamed. That's how the heart of America's most crowded region remains one of its last true frontiers.
Do you know how many continents there are on Earth? That's an easy one, 7. But wait a second, aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist, or at least they used to. They are hiding under other landmasses. Peekaboo! Researchers have recently discovered one continent just like that. It's called Greater Adria. Sound familiar? Yes, it has something to do with the Adriatic Sea. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's eighth continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint – under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low, and that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, and there would still be 7,000 feet between it and sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other, one goes down while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Yep, the coldest and one of the hottest places on Earth were once the same territory. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean. These islands are all that is left of an ancient landmass. They have a cold climate. The islands feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The lost continent's landscape probably resembled that of New Zealand. Now, while we're in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right of the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. But there is evidence of an even greater landmass, the lost continent of Mauritius. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steps of Mauritia. They found a mineral that exists in rocks which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. The local dishes would definitely be spicy. Now, speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Saul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side and the Greater Australia on the other. Back then, Bali stood at the southernmost tip of Asia. Biologists were among the first scientists to notice the split. Species developed differently on Sunda and Sahul. That's why Australia has unique animals, such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. Today, the two islands are separated by the Torres Strait, but it's quite shallow, less than 65 feet. It's a reminder that this was once a single landmass called Saul. Another ocean strait that isn't too deep separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels were 300 feet lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Talk about the ultimate backpacking route. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangaea was a supercontinent that included all of the continents. Its name is in Greek, and it simply means all Earth. But Pangaea started to crack up. The biggest gap formed between the Americas on one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 1 inch per year. Doesn't seem much when compared to the average human lifespan, but in the end, all the continents will reconnect with each other, forming a supercontinent. And it wouldn't be the first time in Earth history that this happens. Honestly, I'm not going to wait around for that. Now quick, how many continents are there on Earth? You'd probably say 7, I would. But honestly, this question doesn't have a right answer anymore. Technically, yes, Earth has 7 continents. But our geography books have been ignoring this whole part of the world. For years, scientists have been arguing that there's actually an 8th continent hiding out there, and it's called Zealandia. Turns out this lost continent isn't so lost anymore. A few years ago, researchers finally mapped out exactly where Zealandia is and how massive it really is. And that was a first, because Zealandia is nothing like the other continents. Think about it. Asia, Europe, Africa, you can spot them from space, or better yet, just look down at your feet. Right now, you are standing on a continent. But most people don't realize every continent on Earth has parts we can't step on, or even see. A lot of their land is hidden under the ocean, and those areas are tough to map or even explore. Now, imagine a continent that's 94% underwater. That'd be almost impossible to find, right? Well, that's Zealandia, a massive chunk of land located beneath the Pacific Ocean. And there's a reason for that. A long, long time ago, Zealandia was part of Gondwana, an ancient supercontinent that included South America, Africa, Antarctica, Australia, and parts of Asia. For millions of years, Gondwana held together until it started breaking apart about 200 million years ago. Its pieces slowly drifted in different directions, and one of them was Zealandia. At first, it was still connected to both Australia and Antarctica. But around 85 million years ago, Zealandia finally split off and began drifting on its own, becoming an isolated continent. Now, unlike Australia or Antarctica, Zealandia didn't stay on the surface for long. It sank. Today, only a small part of it sticks out above the ocean. That's mostly New Zealand, plus New Caledonia, and a few smaller Pacific islands. The rest is hidden under the sea. But hold on, how did Zealandia sink in the first place? For years, most experts thought Zealandia broke away in a process called a strike-slip breakup. That's when continents split apart along huge strike-slip fault zones, places where tectonic plates slide past each other side by side. But something about that theory never quite added up. After years of research, scientists think they have finally cracked the mystery. Turns out Zealandia's crust, or the outer shell of the continent, had been stretched thin. Yep, that's right. Instead of sliding sideways, like they once thought, the land was actually stretching and breaking. It's just like pulling a piece of dough until it gets so thin it finally tears. That's basically what happened to Zealandia. The land stretched so much it eventually snapped, and that happened because the tectonic plates beneath Zealandia were pulling apart, thinning the crust until it finally broke. And when it did, it cracked big time. The cracks were big enough for ocean water to rush in through the gaps, creating what we now know as the Tasman Sea. A few million years later, even more stretching left Zealandia's crust thinner and weaker. Eventually, it gave way, and huge parts of it sank beneath the waves, sealing its fate as a lost continent. But it wasn't all that lost. Experts had actually suspected its existence for almost 400 years, and the big clue was its unusual thickness. You see, Earth's crust comes in two main kinds. We've got continental crust and oceanic crust. They're both part of the planet's outer shell of solid rock, but there are some big differences between them. The continental crust is kind of like a Chicago deep dish pizza. It's thicker. The oceanic crust, on the other hand, is more like a New York slice, thinner. Now let's drop both slices into a tank of water and see what happens. Okay, let's just say the deep dish is lighter, so it floats. That's why continents sit above the ocean. The New York slice is heavier, so it sinks to the bottom of the tank. And that's why oceanic crust ends up lower, forming the ocean floor. There's another key difference too. Continental crust is made of lots of different types of rock, while oceanic crust is mostly basalt, that dark volcanic rock we get from eruptions. Knowing this, scientists used advanced technology to investigate the South Pacific. And what they found was surprising. Areas once thought to be ordinary ocean floor were actually basalt-free and much thicker than ocean crust should be. So wait, could our sunken New York-style pizza actually be a Chicago deep dish? Well, yeah. Even though Zealandia's crust is still thinner than other continents, it's way thicker than real oceanic crust, which means it's not just a patchwork of ocean floor and continental scraps. It's all continental crust, just a drowned version of it. In February 2017, scientists made the big announcement. Listen, everyone, Earth has 8 continents. Ta-da! But back then, they had no idea what Zealandia really looked like. There wasn't a map or anything, and that's probably why so many people still don't know it exists. Even inside the scientific community, not everyone was thrilled about calling it the 8th continent. Some people believe that the strange land at the bottom of the ocean was just a bunch of submerged fragments or microcontinents. Now here's the thing though, even before that big public announcement, an international team had already set sail on an expedition. They went near New Caledonia to collect seabed rock samples from North Zealandia, more precisely from Fairway Ridge in the Coral Sea. Fast forward 6 years, and those very samples unlocked a major discovery about Zealandia: its true size. The combination of rock dating methods, magnetic signatures, and tectonic mapping helped scientists define where Zealandia's boundaries lie. And they found that Zealandia has nearly 2 million square miles of landmass. To put that in perspective, that's about 20 times bigger than New Zealand. For many specialists, its size and completeness basically rule out the idea that Zealandia isn't a real continent. But why doesn't it feel official yet? I mean, we don't see it on maps, right? Well, that's because it's hard to get everyone to agree on calling it a continent. And the biggest reason people resist it so much might be pretty simple. It's just not convenient. You see, continents are generally identified by convention rather than by strict criteria. Depending on the perspective, people recognize 4, 5, 6, or 7 continents, because there's no such thing as a continent authority, and you are not going to see an international commission go on TV to name a new continent, or to make an official list of how many there are. Being almost entirely underwater doesn't help Zealandia's case. I mean, is it really fair to call it a continent, like Asia or Africa? Some people argue that if Zealandia qualifies, then other smaller blocks of continental crust, like the Cocos Islands or other microcontinents, could also make the list. So, how many more continents would we have to add to the list? See why it's not very convenient? Maybe it's safer to call Zealandia a submerged or sunken continent. That's more accurate. Although, to be fair, the true definition of a sunken continent is still kind of fuzzy. But honestly, I wouldn't worry too much about the official definition of Zealandia. What really matters is that fully mapping it is already a big deal. Just keep in mind that large parts of it remain unexplored. Scientists are confident that technologies like seismic imaging and deep-sea drilling will uncover even more about its structure and history. And just because Zealandia is mostly underwater doesn't make it any less of a geological marvel. This sunken landmass actually preserves clues about Earth's past that we might never see on continents above the surface. It might help scientists understand how continents shift as the plates move around. They also hope to find more clues about how drifting continents affect sea level, climate patterns, and the distribution of plants and animals. Each new discovery could sharpen our understanding of how Earth's surface reshapes itself. So, continent or not, Zealandia has already changed how we see our planet. Now, at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot. Ow! Even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. and the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore, but when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lunch, lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangaea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangaea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangaea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So, people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo-Pangaea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novo-Pangaea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangaea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat. If you wander about 1,800 miles from Madagascar into the middle of, well, basically nowhere, you'll reach the Cargillan Islands. This remote French territory is one of the most isolated places on Earth. There's no airport, no native population, not even Wi-Fi, just brutal winds, freezing rain, and rough seas. But this place also hides a massive secret beneath the water, because what you perceive above sea level is only the tip of something far bigger, the peaks of an enormous landmass that mostly sank into the ocean. We're talking about the Cargillan Plateau, a lost, sunken continent. This is a big, mostly submerged volcanic plateau in the southern Indian Ocean. It sits about 1,900 miles southwest of Australia and is nearly 3 times the size of Japan. But don't bother trying to spot it on a world map, because to really see it, you'd have to dive deep. And I mean that literally, since big chunks of it now lie more than 6,000 feet under the ocean. Now, it wasn't always like this, though. For long stretches of time, large parts of the Cargillan Plateau were above sea level, forming a huge microcontinent. That was roughly between 100 million and 20 million years ago. Back then, scientists think this land was covered in dense forests, packed with trees like araucarias and cypresses. But it wasn't exactly peaceful. Active volcanoes were everywhere, with lava flows probably spilling across the land. And not to mention the dinosaurs. There's some evidence that lizards and dinosaurs once lived there, but they were likely the smaller ones, not the big scary kind. Another cool theory is that the Cargillan Plateau once acted like a long land bridge connecting Antarctica and India. People believe that for a long time, but more recent research suggests it's probably not true. Even back then, there were still huge stretches of open water separating these landmasses. But anyway, today the trees are gone, and those ancient volcanoes are quiet, hidden underwater. So, you might be wondering, how did this whole chunk of continent sink and basically disappear? Well, we'll get to that in a second. But first, we need to answer a basic question. How did the Cargillan Plateau form in the first place? Well, our story starts about 130 million years ago. Back then, Earth had Gondwana, a giant supercontinent that included what are now South America, Africa, India, Australia, and Antarctica. But eventually, it began to break apart. And during that long, dramatic breakup that happened over millions of years, the Cargillan Plateau was born. And it basically exists thanks to something called the Cargillan Hotspot. The Cargillan Hotspot is a region deep inside Earth where super hot melted rock slowly rises toward the surface. You can think of it like a steady underground burner, melting rock in the same spot for a very, very long time. And even though the hotspot stays put, Earth's outer shell keeps moving above it. So as the seafloor drifted over the Cargillan hotspot, huge amounts of melted rock spilled out, cooled down, and stacked up, layer after layer. Over about 30 million years, that process built a massive mound of volcanic rock on the ocean floor. At the peak of the eruptions, it may have added around 7 to 8 inches of lava every year. To put that into perspective, that's enough new lava to fill about 184,000 Olympic-sized swimming pools. if there were that many. And little by little, that volcanic pile kept growing, bigger and bigger, higher and higher, until it finally rose above sea level and became the Cargillan Plateau. But then, something strange happened. Over the last 20 million years, this landmass started to sink, slowly but steadily. Today, most of it sits roughly 3,300 to 6,600 feet below sea level, and only a couple of spots have managed to stay above water. One of them is the Cargillan Islands, that French territory we mentioned earlier, and the other is the McDonald Islands, which belong to Australia. Okay, but how did all the rest of it sink? Well, continents don't end up underwater because they suddenly drop like stones. Instead, this process happens because Earth's surface slowly bends, stretches, and shifts over very long periods of time. The outer shell of the planet is broken into huge pieces, the tectonic plates. These plates float on a hotter, softer layer of rock beneath them, known as the mantle. When a continent gets pulled apart by forces deep inside Earth, its crust stretches out, gets thinner, so it starts to sit lower. And as it drops, the ocean doesn't come rushing in all at once. Instead, seawater slowly spills over the edges, flooding the lowest areas first and turning dry land into shallow seas. Meanwhile, the rock underneath cools down, and when it cools, it contracts and sinks, which pulls the surface down even more. On top of that, sediments keep piling up, almost like heavy blankets, adding extra weight and pushing the crust lower and lower. And that's basically what happened to the Cargillan Plateau. Parts of it once rose above sea level and even had forests, but the sheer weight of all that basalt, along with shifting tectonic plates, gradually pushed it back down into the deep ocean. In the end, only the highest volcanic peaks stayed above water, and those are the islands we see today. Now, here's a big question. If most of it is underwater, can we still call it a continent? Well, in a way, yeah. In fact, scientists have described it as a microcontinent since the 1970s. And that's because what really separates continents from ocean basins isn't whether they're above water, it's the type of crust underneath. Earth basically has two main kinds of crust, rising and deep dish. Wait a minute, that's pizza crust. Oops. The Earth's crust comes in either continental or oceanic. Continents are made of continental crust. It's thicker, lighter, and usually much older, so it tends to sit higher and form land. It's also more granite-like in composition, formed from magma that cools slowly deep underground before it hardens. Then there's oceanic crust. That's what the ocean floor is made of. It's thinner, heavier, and much younger, so it sits lower and stays underwater. And it's mostly made of basalt, formed when rock in the Earth's mantle melts and rises up. Now here's where the Cargillan Plateau gets really interesting. Even though the whole region is basically underwater, it isn't just normal ocean floor. And even though it's built from huge amounts of basalt, it doesn't behave like typical oceanic crust. Since this basalt was piled up over millions of years, the crust there became much thicker than normal oceanic crust. It also contains fragments of continental crust from the breakup of Gondwana. So that's basically why we consider it a continent. But you're not going to see the Cargillan Plateau listed as one of Earth's main continents, just like Europe or Africa. And honestly, it's mostly because it would be a headache. A lot of people don't realize this, but the way we label continents is based more on convention than on one strict scientific rule. Because if we started teaching that the Cargillan Plateau counts as a continent, we'd have to take a serious look at a bunch of other places too, like Zealandia, this almost completely submerged chunk of continental crust in Oceania. And it doesn't stop there. There's Beringia, Doggerland, Mauritia, Sahul, and Sunda, all regions that were once dry land or made of continental crust, but are now partly underwater. So, imagine if we started calling all of them continents. Earth would go from having 7 continents to what, 10, 12, more? It would get confusing fast. That's why the Cargillan Plateau is usually described as a microcontinent or a sunken continent, not like a full continent, and certainly never an incontinent. That doesn't make it any less interesting, though. These days, the area is still volcanically active. The eruption rate dropped a lot over time, and has stayed relatively low ever since. But the system is still going, and that's already pretty wild, because activity like this usually only lasts 1 to 5 million years. So, in a way, the Cargillan Plateau behaves like one of Earth's longest-running supervolcano systems, and it's still not done. New Zealand is located in the southwest Pacific, and it isn't just a country of mountains, the world's quirkiest creatures, and hobbit holes. But here's another cool fact. New Zealand sits on top of a hidden continent that's 94% underwater. That's right, just the tip of a sunken landmass more than half the size of Australia. And with sea levels rising, one question keeps, surfacing. Is it possible that all these remarkable creatures will need swimming lessons one day? Zealandia is a sprawling, drowned continent stretching from New Zealand to New Caledonia. This underwater region has mountains, valleys, and its own geological personality. But wait, how can something underwater be called a continent? Well, it turns out being underwater doesn't disqualify you from being a continent. It just makes you harder to spot. Most people think of continents as giant land masses you can walk on. But geologists don't define continents by what's above water. They define them by what they're made of. You see, most of Earth's crust is oceanic, thin, dense, and made of basalt. However, continents sit on continental crust, which is thicker, lighter, and much older. That's the case with Zealandia. Even though it's mostly submerged, it's composed of the same kind of crust as Australia or South America. It has mountain ranges, sediment basins, fault lines, it's not your fault, and even fossils that prove it once had forests and land creatures. Zealandia was above sea level during the age of dinosaurs, and while we haven't found a raptor-like theropod skeleton yet, there's no reason to believe we won't. So how was this discovery made? Since most of Zealandia sits about 1/2 to 1.5 miles underwater, it wasn't easy. We can't drain the region like a bathtub just to take a look. So the answer had to be technology. Scientists used satellites to calculate tiny changes in Earth's gravity to spot what was hiding under the waves. Yep, fun fact, there are satellites that can measure gravity now. For example, NASA's mission GRACE has 2 satellites that find small changes in Earth's gravity. It does this by measuring how far apart the satellites are as they move over different things. Scientists also use sonar to map out the underwater mountains and valleys in 3D. Finally, deep ocean drilling pulled up ancient rock, soil, and even land-based fossils from beneath the seafloor. Physical proof that this wasn't just the ocean floor. Not that scientists use all this tech in that exact order, like following steps on a checklist. It actually took decades of overlapping data from land, sea, and space to connect the dots. By the early 2000s, enough evidence had piled up that some geologists began to speak openly about a possible hidden continent. Still, it wasn't until 2017 that Zealandia was formally proposed as one, backed by clear geological criteria. And in 2023, after decades of mapping and research, Zealandia became the first continent to be fully mapped while almost entirely underwater. But why did it sink in the first place? Long ago, all of Earth's land was joined in a single supercontinent called Pangaea. Around 200 million years ago, I wasn't around then, it began to split apart. The northern half became Laurasia, which included what is now North America, Europe, and most of Asia. The southern half became Gondwana, made up of present-day South America, Africa, Antarctica, Australia, India, and Zealandia. About 85 million years ago, Zealandia broke off from Gondwana. It used to be connected to Australia and Antarctica, but when it split, its crust became too thin and stretched out. That made it less sturdy and more prone to sinking. You can think of it like a piece of ice that floats lower in the water after it breaks off a bigger chunk. Over time, tectonic forces, like plate movement and the loss of its deeper support, caused most of it to sink. It didn't just sink because it was weak, but because it was pulled down by Earth's shifting plates. It settled lower into the mantle because it didn't have the structure to stay higher up. Today, only the highest ridges, like New Zealand, remain above water. That's kind of cool to think about. If Zealandia had never sunk, Wellington would be somewhere up to 9,800 feet high. That's higher than Aspen, Colorado. Now, we know New Zealand is packed with weird and wonderful animals. Birds that can't fly, bugs that glow, sheep that outnumber people. But what about its underwater world? Is it just as special? Actually, yeah. And honestly, maybe even cooler. Zealandia's sunken edges are home to marine life that's just as unique and isolated as the wildlife on land. We're talking thousands of species that evolved in near total obscurity, tucked away on a submerged continental shelf. Think of it as Earth's secret underwater lab. This is all thanks to diverse temperatures and over 50 different habitats in coastal regions alone. Take fish, for example. Some are delicious. But around 300 species found in these waters are endemic, meaning if you don't live near New Zealand, you'll never see them. This cute little fish is called southern lemon sole, and it stands out with its asymmetrical, pancake-like body and the odd habit of burying itself almost completely in sand, leaving just its eyes poking out. And the deeper you go, the stranger it gets. Zealandia's underwater slopes and canyons have creatures that feel like they were designed during a power outage at the Evolution Lab. My favorite is carnivorous sponges. Yep, sponges that eat meat. There are also sea daisies, which are small, flat, round creatures that don't seem to fit neatly into any specific family of animals. Scientists have discovered these unique little animals hanging onto sunken wood more than half a mile deep in the ocean. They're so unusual that researchers almost created a separate category just for them in the Echinoderm family tree, which includes other marine life like starfish and sea urchins. And then there's the New Zealand scamping, a lobster-like crustacean that lives in muddy burrows on the ocean floor. This creature snacks on jelly-like blobs, ghost sharks, and pretty much anything that floats by. Even seaweeds are unique there, although they're not as cool as predatory sponges. Oh, by the way, an interesting fact about the regions close to New Zealand is that they hide active underwater volcanoes. The most famous one is called Brothers Seamount. It's located about 210 miles northeast of New Zealand. It's a massive underwater volcano with a crater at the top, constantly bubbling with heat and chemicals. What makes it fascinating is that these vents, called black smokers, support ecosystems that don't rely on sunlight. Instead, bacteria use chemicals like sulfur to produce energy, a process called chemosynthesis. These bacteria form the base of a food chain that includes species like tube worms and deep-sea shrimp, which are adapted to survive in extreme heat, pressure, and complete darkness. That's not typical for most ocean life, which depends on photosynthesis and stable conditions. Brothers Seamount is also loaded with metals like copper and zinc, making it scientifically valuable and, potentially, commercially tempting. So it goes without saying that Zealandia is incredibly important to scientists. It offers a unique window into Earth's geological and biological history. It's like a time machine and a natural lab that helps scientists piece together Earth's history. So, in the end, could New Zealand end up underwater due to water levels rising naturally with each century? If you're imagining New Zealand slowly disappearing beneath the waves, like a real-life Atlantis myth, don't. Even with sea levels rising, that kind of full-on submersion just isn't likely, even in the worst-case scenario. New Zealand's tallest point, Mount Aoraki, stands over 12,000 feet above sea level. For the ocean to cover that, it would need to rise by more than 2 miles. And unless Earth suddenly turns into a water balloon, that's not happening. Okay, but what about sinking? Could it sink like Zealandia did? Zealandia sank because it had a thin, stretched-out crust. It didn't have the strength to stay up. But New Zealand? It's sitting on the sturdy, lifted backbone of the continent. In fact, thanks to tectonic plate collisions, parts of it are actually rising every year. And not just rising, shaking too. Zealandia has active tectonic plate boundaries, which is why the region gets so many earthquakes and volcanic events. So, while Zealandia may be almost entirely underwater, New Zealand is holding its ground, literally. In other words, the Kiwi won't need swimming lessons anytime soon.
A long time ago, a huge meteorite smashed into the Earth with a horrible destructive power. It was several times bigger than the one that wiped out the dinosaurs 65 million years ago. Luckily, there were no lives it could have taken, or else it would have been a real catastrophe. Now, scientists think it did leave behind a huge footprint, the massive Antarctica impact crater that is bigger than the entire state of New York. The location also has a gravitational Wilkes-Land anomaly going on. At first, scientists noticed something weird here when they measured Earth's gravity in that region, a strange gravity hole, or a negative gravity anomaly. Later, with better technology, they found something even weirder. There was a positive gravity anomaly inside that gravity hole, a spot with stronger gravity. This kind of structure, called a mascon, short for mass concentration, often shows up in places where giant space rocks or meteorites have slammed into the planet. When a meteor hits hard enough, it punches through the Earth's crust and shakes the mantle below. It can spring back up and leave behind a super dense plug of material, which causes stronger gravity right in the center of the crater. It's something like a frosty donut, with ice filling the gap and a dense center rising up from underneath. In 2018, scientists used advanced scanning techniques to study and map the Wilkes-Land meteorite impact in more detail than ever before. They saw that it wasn't a perfect circle, but more of a U-shape, and the northern part looked like something had broken it apart. It possibly happened when Australia split away from Antarctica about 35 million years ago. Some scientists even think you can still see parts of the crater in southern Australia today. This clue also supports the idea that the giant crater under Antarctica formed before the continents broke apart. There have been different ideas about what created this strange formation. Some said it might be a volcano or an eroded valley, or even a sedimentary basin. That is a place where sediments build up over millions of years. But many scientists now believe the most likely explanation is a massive meteor impact. It was possibly one of the biggest to ever hit Earth. A 2015 study even estimated the age of the crater as its size matches the kind of space rocks that smashed into Earth between 4.1 and 3.8 billion years ago. The Wilkes-Land meteorite impact was so powerful because the meteor that caused it could have been up to 30 miles wide. That's 4 to 5 times wider than the Chicxulub meteor that wiped out the dinosaurs 66 million years ago. Even that meteor was enough to cause massive destruction with wildfires, acid rain, tsunamis, and a climate crash that wiped out about 75% of all existing life. So it was lucky in a way that the meteorite that gave us the giant crater under Antarctica visited at a time when there were only microbes and no plants or animals on Earth. It didn't cause mass extinction or leave behind charcoal from ancient fires, but it may have changed the entire planet. Still, scientists haven't put the Wilkes-Land anomaly mystery in the solved files because the crater is buried deep under Antarctica's thick ice sheet. It's hard to study up close. Scientists say we can't rule out the other ideas just yet, but if the meteor theory is right, then the Wilkes-Land crater could be the largest known impact crater on Earth. So far, this title belongs to another contestant, the Vredefort crater in South Africa. Right now, the crater is around 99 miles wide, which is huge. But it's not as wide as the Chicxulub crater in Mexico, which is about 112 miles wide. But the Vredefort crater used to be way bigger, around 155 to 174 miles wide, before time and erosion wore it down. That means even though the Chicxulub impact was striking, the Vredefort impact was likely even more powerful, the biggest one we know of that hit Earth. According to the latest study, That asteroid was 12.4 to 15.5 miles wide and might have hit Earth at a speed of 45,000 to 56,000 miles per hour. It's important for science because knowing the real size of this impact helps us build better models to understand Earth's geology and how giant impacts shape planets, even beyond Earth. Measuring ancient craters is really tricky. Over 2 billion years, erosion wears away the edges and newer rocks form over the crater. That's what happened to Vredefort. Now, only small bits of the original crater rim are visible, and the rest is hidden under newer rock. To figure out its true size, scientists studied minerals like quartz and zircon found around the crater. These minerals still have fractures and shock patterns that show us how powerful the blast was. Wilkes Land anomaly isn't the only case on our planet where gravity is acting weirdly. For over 40 years, scientists were trying to solve a strange mystery in Canada. Parts of the country, especially around Hudson Bay, seem to have less gravity than the rest of the world. That means if you stepped on a scale there, you'd weigh just a tiny bit less than usual. Researchers first discovered this weird difference in the 1960s when they were mapping Earth's gravity. Gravity is linked to mass. The more mass there is, the stronger the gravity. And since Earth isn't shaped perfectly like a ball but is slightly squashed at the poles and bulges at the equator, it makes sense that its mass isn't spread out evenly. So, the first out of the two main theories to explain the Hudson Bay mystery has to do with magma. Yes, that super hot, gooey rock deep under our planet's surface. Magma constantly churns like boiling soup in a process called convection. As this magma moves, it can drag parts of Earth's crust down with it. That makes the area lighter, which lowers the gravity. The second area has to do with the Laurentide ice sheet, a massive glacier that covered much of Canada during the last ice age. This ice was up to 2.3 miles thick in some parts of Hudson's Bay. That's like stacking 10 Empire State Buildings on top of each other. Because it was so heavy, the ice pressed the land down like a thumb on a sponge. Even though the ice melted away about 10,000 years ago, the land underneath is still slowly bouncing back, kind of like a memory foam mattress after you get up. This slow rise is called glacial rebound, and it's happening at less than half an inch per year. Until the land fully bounces back, which could take 5,000 more years, it will continue to have less mass, and that means less gravity. Both of these theories are right. To figure this out, scientists used super advanced satellites, which floated around 300 miles above Earth for several years. These satellites flew in pairs and detected how far apart they were pulled as they passed over areas like Hudson Bay to measure tiny changes in gravity. When the front satellite passed over a low-gravity area, it drifted just slightly, and that change was recorded. Thanks to this research, scientists created detailed maps showing what Hudson Bay looked like during the last ice age. They discovered two huge bulges on the west and east sides, where the ice was thickest. And those spots have the weakest gravity today. The effects of this are still visible, and while sea levels are rising in most parts of the world, the land around Hudson Bay is rising so fast that sea levels there are actually dropping. Solving mysteries like this or the Antarctica impact crater anomaly gives scientists amazing insights into the past of our planet. And by understanding how past changes in temperature and geology affected Earth, scientists can predict how today's human activity can impact our future. A giant crack, more than 2,000 miles long, is splitting open across Africa. Roads, houses, even schools are getting torn apart. Now, scientists think they've finally figured out what's causing it. An enormous column of scorching hot rock called superplume, rising from deep inside the Earth. And it's slowly pushing the land apart inch by inch. This isn't a small shift though. The continent is breaking in two, and the clue to what's going on could be hidden thousands of miles away in Hawaii. And why does the United States suddenly have a role in all of this? Hang on, we'll get there. First, it's important to know this isn't new information. Africa has been slowly splitting for about 25 million years. This is happening in a region called the East African Rift System. It stretches thousands of miles from Ethiopia down to Mozambique and is the largest active continental rift system on the planet. And by that, I mean places where the Earth's crust is being stretched and pulled apart, causing faults, earthquakes, and volcanic eruptions. Scary stuff to say the least. Back in 2018, for example, a massive crack appeared near a small town just west of Kenya's capital, Nairobi. In some spots, it was about 65 feet wide. That's almost the length of 2 school buses parked one after the other. The whole thing was terrifying. It happened fast and left a trail of destruction. Roads were cut off, farms torn apart. People were on edge as the ground opened up beneath their feet. And I mean that quite literally. One man watched the crack rip straight through his home. He barely had time to grab a few of his belongings before his entire house collapsed. Sounds terrifying, right? Since it happened in the East African Rift region, panic spread fast. The media was all over it, claiming it was proof that Africa is splitting apart. People standing near the crack thought, oh boy, it's already happening. And many still believe that today. But that's not actually the case. At least not with that particular crack. Because after the initial panic, videos and photos of it revealed clues that it wasn't related to tectonic plate movement. First clue, the 2 sides of the crack didn't match. Like trying to fit the wrong puzzle pieces together. They simply didn't line up. Second clue, the gap wasn't one continuous line. There was some kind of soil bridges in between. All this showed it was sudden erosion. I mean, some specialists believe the crack had once been filled with volcanic ash from nearby Mount Longonot. But then the region was hit with heavy rains. When water soaked through the soil, it washed the ash away, leaving the gap exposed. Problem solved. Even after the truth came out, it was too late. This event brought the whole Africa is splitting talk back. And here's the thing. Even though that crack had nothing to do with it, make no mistake, Africa is breaking apart. That's because the continent sits between 2 tectonic plates, the Somali Plate in the east and the Nubian Plate in the west. The problem is they're moving away from each other, and as they drift apart, the gap in the East African Rift keeps getting wider. Eventually, the Somali Plate could split completely from the Nubian Plate, creating an entirely new landmass. Something on the scale of Madagascar or even New Zealand. You don't have to worry though. This process is super slow. So slow that none of us will see it finished. Experts say the continent is moving apart by about 0.3 inches a year in some places. To give you an idea, that's less than the length of your fingernail. So we can say this split will take millions of years, which is good news for the people living there. But that doesn't mean they won't feel the effects of this slow break. In fact, they're already happening. Take Ethiopia's Afar region, for example. Back in 2005, this area showed just how unpredictable the rift can be. In a short period, 420 earthquakes hit the area, opening up a massive fissure. What usually takes centuries happened in just a few days, completely challenging what scientists thought they knew about the speed of geological changes. Back then, the crack stretched for more than 35 miles, and life around it is still far from easy. Recent earthquakes destroyed much of the local infrastructure. 37 schools were damaged, leaving 5,000 students without classrooms. And that was just one part of the damage. As the tectonic plates keep moving apart, water will eventually flood into this region, creating a brand new ocean, according to some predictions. Countries like Zambia and Uganda, which are landlocked today, could one day have a coastline. That could be great news for them, as it might open up new trade routes and completely reshape their economies. Don't get too excited though. We won't be diving into the waters of this 6th ocean anytime soon. The splitting process will take another 5 to 10 million years. But it's tough to say exactly when, since big seismic events, like earthquakes, could make it all happen faster. So here's what we know. The Somali Plate and the Nubian Plate are in the middle of a dramatic tectonic breakup, slowly moving apart. Africa is breaking in two. Earth will probably gain a new ocean because of it. But until recently, we didn't know exactly what was triggering all of this. Like, yeah, those tectonic plates are moving, but why? I mean, is this massive geological process being driven by something happening in Earth's mantle? Or could it have a much larger, deeper source? Well, scientists think they may have finally cracked the mystery. They believe the continent is breaking apart because there's a deep mantle superplume, a huge column of hot rock beneath the East African Rift system. Think of it as a massive subterranean hammer pushing upward, pressing against the crust, and slowly cracking it apart. But here's the interesting thing. Scientists reached that conclusion thanks to something that happened in a completely different part of the world, Hawaii. Under this US state, there's also a plume of super hot rock rising from deep inside the planet. It melts the crust above it, and that's what fuels Hawaii's volcanoes. As the Pacific Plate drifts over this plume, molten rock breaks through in new spots, creating volcano after volcano. Over millions of years, that's how the Hawaiian Islands were formed. This Hawaiian plume contains noble gases like helium and neon. And you know where else scientists found those same gases? That's right, beneath the East African Rift system. Bingo! That discovery backed up the theory that a superplume is driving what's happening in Africa. And we call it super because it might be massive. You see, these same gases have been found in volcanic rocks from Kenya all the way down to Malawi. So everything points to the existence of a single superplume that stretches from the Indian Ocean to the Red Sea, not a bunch of several isolated sources. If their data and research are correct, scientists estimate that this superplume beneath Africa likely starts at the core mantle boundary, which is located about 1,800 miles deep inside the Earth. While the East African Rift system's chemical signatures are similar to those found in volcanic rocks in Hawaii, they're not identical. The Hawaiian plume is thought to be a narrow, rising stream of hot mantle, a bit like the movement inside a lava lamp. Africa's plume might be shaped differently, more like a large mass of hot, buoyant material rising from deep within the Earth. As it reaches the surface, this hot material hits the colder, solid outer layer and spreads out, pushing hard enough to crack it open and trigger intense volcanic activity across the region. And if this theory is right, we're watching a slow but unstoppable force that will redraw Africa's map and change the continent forever.
Wow, this port is so buzzing. Thousands of people come here every day to work, cargoes come and go, fishers are weighing their catches for the day, and even posh cruise ships pop in here to show this idyllic place to all the people on vacay. The ocean shore is fantastic. People walk along the beach eating ice cream or building sandcastles. Oh, and by the way, right now we're standing where the Sahara Desert used to be. Normally our lifetime is too short to see any major changes. We don't notice mountains rise or the way rivers change their course. Entire valleys may be sinking, but it usually takes too long for them to sink entirely. Still, a group of scientists recently noticed there's a new ocean being formed really fast, and we can even witness it appear. Look here! It's the Afar Triangle. There's the Horn of Africa Peninsula not far away. It's the exact site where the sixth ocean is being born at the moment. Wherever you are, you're basically standing or sitting on a tectonic plate. You're just sitting on a couch watching this video? Cool! Your couch is standing on the floor, your floor makes part of your house is standing on the ground, and if you take a deeper look, it all stands on one of 15 principal tectonic plates. Together, these chunks are referred to as lithosphere. It's like a nice apple pie. The crust is the lithosphere, and the fragile apple filling is everything that's on the planet's surface. If the crust cracks, the filling leaks out. And this is what any earthquake is like. A tectonic plate, aka the crust, moves. The filling, also known as houses and people, is disturbed. Africa is made up of two plates, the Nubian and the Somali ones. Yeah, that's a large pie. And it seems like these two plates are constantly separating. It leads to an oceanic spreading ridge. It looks like the African continent is literally unzipping a part of it at this moment. A 345 square mile chunk of the Sahara Desert just split, so the magma rose. It triggered a series of earthquakes across Ethiopia, Eritrea, and Djibouti. And it's not just some minor earthquake. There are lots of fumes rising from those fissures, and it smells like sulfur. Phew! The eruptions slowly push the old lava sediments away, which is followed by creation of the new seafloor. The crack is filled with magma, and when it cools, it forms the new oceanic floor. If this process doesn't stop, the Red Sea will finally flood the area, forming the Sixth Ocean, and Africa will be split into two parts. So we'll basically have two Africas. But wait. Neither you nor your grandchildren are going to see that Sixth Ocean. You'll only have 5 of them throughout your life. Same with our future generations. Same old Pacific, Atlantic, Indian, Arctic, and the Southern Oceans. Before the oceanic floor gets solid, and before the Red Sea actually starts flowing in there, many thousands, if not millions of years must pass. The continents move as fast as your nails grow. And imagine that the longest nail ever seen in history was the thumbnail of an Indian man reaching almost 6.5 feet before he cut his nails. It took him almost 60 years to grow it. Now think how far the continents will have to move by the time you celebrate your 100th birthday. Spoiler, it's not going to be very far. But anyway, you can witness some minor changes that take place even now. All those cracks that may not seem that significant so far make all the landscape in the Afar region look really unique. There's a couple more reasons for this uniqueness. Meet Erta Ale in Ethiopia, the volcano famous for its world's longest-lasting lava lake. It's located in the Afar Depression, also known as the Afar Triangle. By the way, depression refers to the sunken area. There's nothing sad about it. It's not the only volcano in this area. Eritrea, known as the Nabro volcano. It's never erupted, yet the lava in this area is pretty active. More volcanoes are to come because of the tectonic plate movements. They pull away from each other, and the Earth's crust gets thinner. The weaker the area is, the more volcanoes there are. Okay, the plates are separating, and it's kind of inevitable. It's just the question of time. This process is also called the Afar plume. We'll get more volcanoes, it's inevitable either. But how does it happen? Remember that apple pie? Yes, it was delicious. Well, things are actually much more complicated. The outer layer we walk on is relatively delicate and is made up of multiple broken pieces. It's like the eggshell or a lattice top on a pie. Let's take a deeper look at all the ingredients of this pie. If you cut a slice, you'll see it's made up of many parts. And there's something called the asthenosphere under the lithosphere. It's part of the Earth's mantle. Yeah, complicated. So the asthenosphere gets heated from within and it rises, just like the dough when you put it in the oven. Remember those cracks on the surface of a freshly baked loaf of bread? Man, I'm getting hungry. Anyway, this is basically what happens to the Afar Triangle, and those cracks make this area split, creating those famous rifts and valleys that will possibly become so large and will probably get flooded so that the world's sixth ocean will appear there soon. Or not. Nobody's sure about it. Okay, but since the tectonic plates and, which is logical, all the continents are always on the move, we'll probably have more continents in the future. The answer is yes and no. If a part of Africa does split, we'll get one more continent, which is going to be even smaller than Australia. But there's one more possible way of how things will go. Chances are, in the next 250 million years, in the distant 250 million years, there will be no more transatlantic flights. And a walking trip from Japan to Chile will be possible too. Way too long, but possible. It's all happening now, and the first results will be noticeable in some 50 million years from today. I won't be around then. Australia will move towards Southeast Asia, and it's going to fit in just perfectly. And Africa will be pushed to Southern Europe. Still, these transformations will take a really long time. People and continents have something in common. Remember that continents move as fast as our hair and nails grow, just about 1.2 inches a month. Some of them move even 5 times faster though, But even this speed is too slow for 4,500 miles distance between Africa and Europe. One theory tells us the things we've already seen before. Well, you didn't see that with your own eyes. Neither did any of your ancestors who came to America across the Atlantic hundreds of years ago. The fact is, all the continents were once one landmass known as the Pangaea supercontinent. Even though it formed over 300 million years ago and split about 180 million years ago, give or take, it might come back together. So kangaroos can easily migrate from Australia to the UK if they feel like it, but the latter might be accidentally crashed while all the continents merge together. The Americas would collide, Antarctica would drift to them, and it all will merge with the already collided Africa-Eurasia. In this scenario, one large ocean and one large continent will appear, namely Novo Pangaea. Another possible scenario claims the continents might merge into the uniform landmass or form a circle with a large sea inside and the super Pacific Ocean outside. This continent is referred to as Pangaea Ultima. The third theory might be already coming to life. The Pacific and the Atlantic Oceans might just cease to exist, forming the new ocean basin. Eurasia will be split to form a new ocean, and all the continents will migrate to merge into the supercontinent Orica. And the fourth and last theory claims that the Pacific and the Atlantic Oceans will remain almost unchanged, and all the continents but Antarctica will merge into one, leaving poor Antarctica even more isolated and abandoned than it is now. Nah, don't feel bad. Since all the continents keep drifting northwards even now, it's quite probable that almost all of them will meet up somewhere at the North Pole.
Whoa, there could have been more human species throughout history than we used to think. In one place in East China, Hualongdong, scientists found the remains of a human who lived around 300,000 years ago. They found a jawbone and parts of the skull. They carefully studied these bones to compare them with the bones of other ancient and modern humans. The remains themselves weren't that unusual. We know our human family is really diverse and has been around for millions of years. You know our ancient relative called Australopithecus, right? These fellas lived in different parts of Africa, and they were known for walking on two legs, just like modern humans. But their brains and some other parts of their bodies made them more similar to apes. Their teeth are a good example of how they were like a mix of apes and modern humans. Their canine teeth were smaller than those of apes, but their back teeth were still larger than ours. There were different types of them. You can recognize some Paranthropus because of their big jaws and teeth. One of the most famous fossils of Australopithecus is Lucy, a lady that's about 3.2 million years old. She was found in Ethiopia. So, we know that our family got pretty big from that point, or probably even before it. But it's always great to welcome some new members, which seemed to be the case with this new discovery. Some parts of these bones look similar to the bones of ancient humans, while other parts look more like the bones modern humans have. For example, the person whose bones they found didn't have a real chin. That means we can't put it in any of the groups we know of, like Neanderthals, or maybe even Homo sapiens. So, might we be missing a branch from the human family tree, or an important step in our evolution? What we're looking at here could be some mix between the creatures that became modern humans like us, and the ones that turned into what we today know as Denisovans. It takes time to figure it all out, though. We hadn't known much about Denisovans either, until we found some of their bones in a cave in the mountains. These bones are really rare, and we only had a few pieces to analyze, but their genes told us a lot more about their past than their fossils. Different kinds of humans lived on this planet, but through time, they spread around. One group started living in Africa. Those are our kind, Homo sapiens. Another group went to Europe. That's how we got Neanderthals. But some of these ancient human groups moved all the way to Asia. That's where we can trace a new interesting kind, Denisovans. It seems they're cousins to both modern humans and Neanderthals. The three species actually shared a common ancestor about 765,000 years ago. It's still not clear why Neanderthals and Denisovans took different paths, but one theory says that it was mostly because the Arctic ice sheet expanded southward all the way to the Black Sea, cutting off Europe from Asia. Life, or better yet, the planet, kept them separated for a very long time. Plus, they kept changing places where they lived all the time, always looking for something better, like every other human species before and after them. But this didn't last forever. Scientists found genes from two groups of Denisovans, one in mainland Asia and the other in a place called Melanesia. So not only did they have different groups within their populations, but it also seems that after thousands and thousands of years of developing independently, the members of these three populations, Neanderthal, Denisovans, and modern humans, somehow met again and spread all across the land. 5% of the Denisovan genome lives not in the area where scientists found their bones, but in people that live thousands of miles away in Southeast Asia, for instance, in Papua New Guinea. But scientists believe that the cave where they found the remains of Denisovans might be as far north as they had lived. It would have been way too cold for them to survive if they had gone further north. From there, they traveled as far south as Indonesia. This was possible because, during their time, sea levels were lower than today. So Indonesia was connected to mainland Asia. But they probably didn't make it to Australia since it was still separated by water. These three groups mixed together too. Scientists have found a bone of a girl who had a Neanderthal mom and a Denisovan dad. It's the only first-generation hybrid human we've discovered. She even got a cool nickname, Denny. One of the mysteries about Denisovans is how they disappeared. Maybe they mixed so much with other humans that they just blended in. Or it's possible that modern humans' ancestors were stronger, had better tools, or even brought some diseases that didn't affect them, but affect Denisovans. Climate and where they lived might have also played a role. Denisovans lived in a wide range of environments, from cold parts of Asia to tropical Indonesia. Climate changes and the challenges of different habitats might have been really difficult to survive. But it's hard to draw strict lines in our family tree. We're still relatively new at learning about it anyway. Who knows how many new members we are about to discover? Half a century ago, a team of scientists had an idea that a collection of fossils they found at the Great Rift Valley in Tanzania were actually the remains of some new human species. Yup, that was the time when we welcomed Homo habilis into the family. It was a big discovery at that time since people mostly believed that the story of our evolution had been really simple. First, there were Australopiths that looked like apes. After them, there was Homo erectus, the upright man. They most likely lived in Africa around 2 million years ago, but also expanded really quickly across Eurasia. It was the first human species that we know about to have traveled such long distances to find a better place for life. They looked and behaved like humans. Plus, they were probably the first of our ancient ancestors who learned how to deal with fire. Maybe they were the first to cook food as well, and that's what we're definitely thankful for. Cooking food was an innovation that made the human diet more nutritive, and we could grow bigger and smarter brains. So, yeah, Homo habilis made things more complicated. They could walk on 2 legs, but they could also be better at climbing trees than walking on the ground like us. Plus, their brains were smaller than what a human should probably have. At first, it seemed these fossils could be from a completely different side of the family, related to other creatures, Australopithecus africanus, that looked like apes. But more and more digging showed that even though its jaws and teeth were similar, Homo habilis was still bigger and a bit different. The name means handy man, because they were probably able to make and use simple tools. Searching for more fossils in Africa wasn't easy because a team of researchers had to deal with wild animals and tough conditions all the time. But eventually, they managed to find some teeth and a strange skull that was, Again, something different from the ancestors we knew about. The teeth were really big, so this new fella got the nickname of Nutcracker Man. For a long time, everyone believed this kind had evolved to eat hard foods. But the fossil teeth didn't show much damage, so they might have been eating food that was softer than we thought. This finding might help us understand how our teeth have been evolving through time, too. And right there, in the same layers of soil where Nutcracker Man was lying, they found ancient stone tools. At first they thought those had belonged to Nutcracker, but as they kept digging, they found more fossils that didn't match Nutcracker Man. It means that someone else must be the real tool maker. But that's another story for another time.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share